Hello students, good evening. Welcome to another video, and today you might have all seen the thumbnail. We are going to discuss first PUC portions. Okay, are you all excited? Yes, are you all there? Am I live? Okay, one second, let me just hello. Good evening everybody. Oh, so many red flags. What is that? Yeah, we will do fast revision. So today we'll be covering only important first few topic, and that is only in KCET perspective. So I will not be discussing any derivation or anything that long. We'll only do things that you need for KCET. Okay? So yes. Good evening, Ritu. Hi, Tarun. Hello, Suresh. Okay, so we will start in a minute. We will start from chapter 1 and we'll go all the way till waves. Alright? So I want you all with full energy today. Now, why first PU? Because not a lot of people do videos on first PU. So I thought, I'll help you all with first PU and you will get 20 to 25 marks from first PU. And usually the questions are easier from first PU. So I don't want any of you to miss out on the first PU questions. Okay? So let's start. Yes, let's start. My video is lagging. Can you confirm if my video is fine? Is my video lagging? Someone said my video is lagging. I can't pronounce your name. I'm very sorry, dear. Can you just let me in the chat if my video is lagging or not, and then we'll start. It's breaking. Is it breaking or lagging? Okay, fine. So let's start. Thank you, Preetham. Okay. All right. Thank you, students, for confirming. Let's begin. First PU revision one shot. I hope you all have the energy and I have the energy too. So let's start. First chapter is the most easiest chapter, units and measurements. So in units and measurements, we will look at all the important things only. First thing, finding significant figures. So this is something that all of you will know, but we will just go through everything. So we'll go through this as well. So let's look at an example here. Okay. So first thing you need to know for significant figures, any non-zero digit you have like 1, 2, 3, 4, 5, 6, 7, 8, 9. All of these are non-zero digits. They are all significant. Now, if there is a zero between two digits like 505, if it's like 505, then that zero is significant. So a zero between two significant digits like two non-zero digits, that is significant. Example 201, 101, 510. Okay. So in 5, okay, we'll go to that. So third rule, for any value less than 1, zeros after decimal and before non-zero digits are not significant. Okay. So 0 before decimal in such a number is always significant. Now, if you have trailing zeros in a number like 500 without a decimal place, then the number of significant figure there is 1. Okay, so imagine you have 800. How many significant figures will 800 have? Quickly let me know in the chats. 800 will have how many significant figures? It will have only 1 significant figures because trailing zeros after a digit is not significant. But now what happens? What if I introduce a decimal? What if I make it 8.00? So 800 I make it 8.00. Then what happens? It is 3 significant figures. It becomes significant. Okay. So let's look at these examples. So first one, 2987 has 4 significant figures because they're all non-zero. 406 has 3 significant figures because the 0 is in between 2 significant digits. 100 has only 1 significant figure because trailing zeros are not included. But look at the decimals. Look at this. 4.330 has 4 significant figures because a 0 after a decimal is always significant. See, 343.000. It also has 6 significant figures. But a 0 before a decimal is not significant. That is why 0.543. You can look at this example. 0.5. Oh, I can use my pen. Why am I not using it? Yeah, 0.543 has only 3 significant figures. That is because before a decimal, if you have a 0, it is not significant. Now, 10 powers, not significant. So, 1.32 into 10 raised to minus 2 will have only 3 significant figures. Alright. Now, when you add or subtract, what do? So, let's take an example. 2.56 plus 1.209 is, in reality, it is 3.76. Some more decimals are there, but you only take 3 decimals. Why? Because when you add, the least number of decimal places is 2. That is why you take only 7 and 6, 2. Okay. So, whenever you add or subtract or multiply or divide, your answer should have the number of significant figures which is same as the least significant figure number. For example, look at the second example. 2.56 has 3 significant figures. 1.205 has 4 significant figures. So, which is the lowest? 3. So, your answer should have only 3 significant figures. That is 3.08. It's lagging and breaking. Students, some of them are saying my video is lagging. Can the others confirm? Is my video lagging? Let me check. On my device, it's fine. Some of them are saying the video is lagging. Yeah. Can you all please let me know in the chats if it's fine? Because on my phone, I can see it fine. Quickly, students. Savio says it's fine. Others? Gagan, is it fine now? Okay, fine, Gagan. Alright. Okay, fine, students. Yeah. I can't sit and see the full video. No, I'm teaching. Okay, Gagan, thank you. Okay, so significant figures clear. That's the most simplest topic. Can you all put some? Preetham, how do you know mine's 5G phone? Okay. Alright, students. Now, can you all let me know in the chats if significant figures is clear to you? Were you able to understand because it was lagging? Anyway, significant figures is something I know all of you know, but then I wanted to explain everything because if there's one person who doesn't know, I should help him, no? Him or her. No gender bias. Okay, next important thing is dimensional formula. Okay, so dimensional formula, what are the 3 main dimensions? The 3 main dimensions are M, L and T. M for mass, L for length, T for time. How do you do dimensional formula? To do that, you need to know basic formulas. For example, let's take area. How do I find the dimension of area? I first write down the formula for area. Area is length into breadth. What is length? Length is a length. So it's L. So its dimension is L. Breadth is also L. So its dimension will be L square. Okay. So the whole dimension. So sometimes in your exam, it will be given to you as M0 L square T0. So M0 means it's not there. T0 means it's not there. This is a very easy one. You won't get such easy ones. So I have so many dimensions you can practice on. Okay. I have put how many? 35 of them. So you can randomly practice all of these. Let's randomly do one more. We will do universal gravitational constant that has been asked in one of the previous year papers. So universal gravitational constant, what is the formula? G is equal to If you students quickly let me know. It's fine now, no, the video? The video, is it fine now? Yeah, it's fine now. Okay. So, yeah, we will do universal gravitational constant. So, how do I do that? Click. Okay. What's happening? System's not responding. Just a second, students. I'm really sorry, but OneNote just closed by itself. Just a second, student. Please give me a minute. I will rectify this. One second, 1 second. No, sometimes days are bad. You have these technical issues which you don't know come out of nowhere. This was all running fine. I'm really sorry. Really sorry to waste your time. Just a minute, I will. I know your time is very important and you're all studying so hard, but there's nothing I can do. I'm just a second. Okay, yeah. So dimension is what we were discussing. Okay, let's find out the dimension of universal gravitational constant as I was saying. So F is equal to gm1 m2 by r square. So first thing you need to know the formula. So fr square by m1 m2 is g. It's good if you can know the dimension of basic stuff like force. Lagging again. Okay, it's lagging again. Why is it lagging so much? Sound is fine. It's still not fine. You have to restart. Is it okay now? I don't know. I used the same system, same internet. It was fine. I don't know what's wrong now. Still not fine. Okay, I think I should restart the system. This thing. Oh, so it's just my face that's the problem. Everything else is fine. Can someone clearly tell me what the problem is? Okay, I'm going to continue anyways. Some say it's fine, some say it's not, but let's continue. Because I can't waste a lot of time. You all have to go back and study. Alright, so let's do it. F is equal to what am I doing? Yeah, I'm going to find out the dimension of universal gravitational constant. So it's good if you know the dimension of some basic fundamental quantities like force. What is force? Force is mass into acceleration. The dimension of acceleration is Lt raised to minus 2. So force would be mLt raised to minus 2. R square will be L square and this would be m square. So what would it be? Cancel. M L cube m L cube t raised to minus 2. Is it? Let's go check. Hey, where is universal gravitation constant? Yeah, right, no? M raised to minus 1, L cube t raised to minus 2. Now, when you do your boards, brackets and all that is important, but for KCET, none of that is important. You only need to get the powers correct. So, the only way to do dimension is to know your formulas well. Okay. So, make sure you know your formulas well and do your dimensions. Is dimensions clear to all of you? Shall we move on? Sorry for wasting your time in between. Let's just move on. Now, another one. Let's just do torque as well. Torque is what? Moment of inertia times angular acceleration. Can you see my screen? Okay. So torque is moment of inertia times angular acceleration. Let's do torque. So for torque, the dimension formula will be, you need to know the dimension formula for moment of inertia. How much is that? mLt raised to minus 2 times. So for torque, you can actually use different formulas. You can, another important, easy one you can do for torque is, you can just consider torque as force into distance. So that's more easier because you know the dimension for force. So ml square t raised to minus 2. You need not put this formula. So another thing you can study from here is some things have different formulas. The easiest formula is where you can find out the dimension. How to control fear? Why do you get scared? You can relax and study. Okay. Next one, homogeneity principle. Is dimension clear? Can I have some fire emojis in the chat just to know that all of you are here? Ma'am, we can't see clearly. Ma'am, lagging. Can't see clearly. King Pro, you have a doubt. What's your doubt? Is dimension clear now? Do you want me to explain it once again? Oh my god. I don't like technical glitches. No, these are things that are out of our hand. Is it fine? Can I have some fire in the chat if it's fine? Let's just... Okay. Okay, students, are you all right? Are you able to? Okay. I'm just looking down because I'm looking at the chat, okay? All right. Fine. Okay. Okay. Next is the homogeneity principle. So here, what you should know is dimensions on the RHS and the LHS should be the same. Okay. For example, if I have F is equal to MA. Okay. What is the dimension of force? M L T raised to minus 2. This should be the same as the dimension of M and A. What is the dimension of M? M. A is L T raised to minus 2. So dimensions on the left side and the right side should be the same. That is the first thing. Next is, if A and B are two different dimensions, then you cannot add them. What do I mean by two different dimensions? Let's say I have force and I have temperature. Force has a dimension of mLt raised to minus 2 What is the dimension of temperature? It does not have mass, length, nor time. So it would be 0. Can I add force and time? You can't add 2 newtons minus 2 seconds. You cannot do that. You cannot do 2 newtons plus 2 seconds. So if you have 2 different dimensions of 2 different quantities, you cannot add them nor subtract them. But you can multiply them or divide them. This was asked in a previous year KCET. I have network issue. Network issue. Alright. So that time what was asked is they gave you A and B and they told you A and B are of 2 different dimensions. And the question was, can A minus B be done? Okay. It cannot be done if A and B are different dimensions. Alright. Next. Next is errors. This was also asked in a previous. Now this is still lagging. Okay. This was asked in a previous year paper. This is errors. Okay. So first we will look at absolute error. What is absolute error? So imagine you have x is equal to a plus or minus b. How will you find out the error in this? You take x as delta x. So delta x is equal to delta a plus or minus delta b. Okay. Students, if my video is lagging, you listen to my voice. As long as the screen and my voice is visible, it's fine. We can have the class. Alright. I am using 5G. I use the same internet for all the classes. I don't know what's wrong today. Okay. So x is equal to a plus or minus b. So if I am to find out the error bar will be for x it will be delta x, for a it will be delta a, it will be plus or minus delta b. Now when you have multiplication or division, the errors will actually be multiplied or divided. You can see here. So let's say again x is equal to a plus or minus b. So if I am doing multiplication or division, the errors will be like this. Delta b by b. You can see for addition it was added. These are called relative errors. Now if you have a power, like for example if you have x is equal to a raised to n, then the error of x will be delta x by x will be n into delta a by a. Okay. Now if you want to find out the percentage error, it will be this delta x by x into 100 will give you the percentage. Okay. Thank you, Ritu. See, there will be easy questions and difficult questions. I will show you a question with what I just solved. See? Okay, we'll finish it and I'll show you questions. Students, I want you to relax. Okay? We will solve everything today. We will do everything today. But if you keep asking me, then I'll not be able to move forward. Alright? Next is powers. So, x is equal to a raised to m, b raised to n, c raised to p. Okay. Now the question is find out the relative error. So the question is find out relative error. So what will you do? Now they will give you values in the question. They'll give you the original value is 5.5. The error is 0.5. Now find out the relative error. So what you will do is you will take the error value divided by the original value, which will be equal to the power into again error value by original value plus power into error value divided by original value plus p into error value by original value. Is this fine? I'll show you a question for all those who are asking me, ma'am, will all these come? This was a previous year KCET question. It came in 2019. See, a cylindrical wire has a mass of 0.3 plus or minus 0.003. So 0.3 is the actual value, your x. 0.003 is your delta x. Radius is 0.5. Again, this is r. This is delta r. Length, so this is L. This is delta L. How will you do it? Quickly, you should be able to do it. First, we'll write down the formula. You have to do density, right? So, density is mass by mass by volume, right? So instead of volume, I'll write it as area into h, because these two are given to you. Area into length or whatever. See, what is this is area into length. Why did I take area? Because I have radius. So I can take it as pi r square and then L. Now r has a power. It's r square. So you have to do power as well. So let's do the error. I will use yellow because it will be a little more. So what happens? Delta P by P will be equal to delta M by M plus radius square. So 2 into delta R by R plus delta L by L. Now you just have to substitute the values. Delta P is 0.003. So delta P is 0.003. P is 0.3. This is going to be equal to delta M is 0.05. M is 0.5 plus 2. Why did I put 2 here? Because it was R square. Delta R is how much? Sorry. Delta M is not given to you. Sorry, delta P is not given to you. Rho. So delta P by P is equal to all of this. 0.003 by 0.3 plus 2 times 0.005 by 0.5 plus 0.006 by 6, and you just have to do the math. So all of this will be 0.01 and all that. So this becomes 0.01 plus 0.02 plus 0.01, which is 0.04. Okay, now the question is what percentage? So for percentage, we already learned this is the formula. So 0.04 into 100, 4%. Is that clear? Can I have some fire emojis if this is clear to all of you? We'll move on. So that's all that you need to. Yes, I am doing important concepts. I'll do all important concepts. If this is clear, can you put some thumbs ups or some fire emojis? Okay. So this is all that you need from the first chapter. What all you need to know to find significant figures? You need to know to find the dimension. You need to know errors. Also, you need to know dimension, the properties. You cannot add or subtract two different dimensions. You can multiply or divide them. Okay. This is all that you need to know from your first chapter. If you know this well, practice dimensions well. It has come in some papers, it has not come. You will get one out of these. Okay? You might get errors, you might get dimension, you might get significant figures. So practice all of these. These are things that you will easily score. You will not lose marks here. Okay, next we will move on to chapter 2. Motion in a straight line. Okay? Shall we move on to chapter 2? Yes, metrics I will do all important concepts. Till last waves I will do. Okay. Okay, motion in a straight line. So first thing you need to know what is instantaneous speed. So I saw average speed is not there. So that's why I start with instantaneous speed. So instantaneous speed is the speed at one small instance. Okay, for example, you're driving. Okay, and you say, you look at the speedometer. At that one instance, whatever your speed is, that is instantaneous speed. And how do you get what is the formula for that? It is change in distance by change in time at that one point. That is instantaneous speed. Okay. So in your question, if they give you the distance is this much, the time is distance, you just have to do dx by dt to get d. Is that fine? Next is instantaneous acceleration is how change in acceleration divided by change in time. Sorry. Instantaneous acceleration, change in velocity by change in time. dv by dt. Simple concepts. Next is very important, graphs. Okay, so graphs are very important because they might ask you, give you graphs and ask you to find out what the graph represents. Okay, so these are graphs having displacement on the y-axis and time on the x-axis. So what will a straight line like this represent? A straight line like this in a distance time graph will represent what? It means that the object is at rest. How does it mean that the object is at rest? See, this is how the line is. So that means at 2 seconds, 4 seconds, 10 seconds, or even after 1 hour, you are at the same distance. let's say your distance is 10 meters. You are at 10 meters for the whole time. Time is moving, but your distance is not moving. That means you are simply sitting. That's why you are not moving. See, I am sitting here. Even after 1 hour, I am sitting here itself. So if I plot a graph on how I move, my graph will be like A. It will be a straight line. So a straight line like this represents object at rest. Now, a line like this, what does it represent? It means that the distance is continuously increasing with time. So this means uniform velocity. So every 2 seconds, you travel 2 meters. So 2, 4, 6, 8, 2, 4, 6, 8. So every 2, 2, 2, the speed will continuously increase. So it is uniformly increasing. So it's called uniform velocity. So B is uniform velocity. Okay. Now what is C? C is just a curve. It does not have a pattern. So any curve like this, it just means velocity is increasing, but it's not uniform. If it's uniform, it would be a line like this. Alright. Uniform velocity is like this. Any doubts here? So these are all distance time graph. You have to be careful. There's distance or displacement. It does not matter on the y-axis and time on the x-axis. Now, let's put velocity on the y-axis. Now, if I have velocity on the y-axis, a straight line like this wouldn't represent that I am not moving. If I had distance, this meant that I was not moving. It just meant constant, rest, right? But on a velocity time graph, this means that every time my speed is the same, which means I'm moving at, let's say I'm moving at 20 meters per second. I'm moving at 20 meters per second, 20, 20, 20, 20. Like for 1 hour, I'm moving at 20. That means I am moving. I'm not at rest, but I'm moving with constant speed. Okay? Now, if I have a graph like this, it means uniform acceleration. For distance time graph, a graph like this was uniform velocity. Here it is uniform acceleration. Now, a random graph like this is non-uniform, but it's increasing, so it's acceleration. And if it's coming down, it's deceleration. Is this clear? These graphs are important. They're very simple, but important as well. Okay? Next is acceleration time graph. So the first one was distance time graph. Second one was velocity time graph. Now it's acceleration time graph. Now see, on acceleration time graph, what does this mean? That means there is no acceleration. So whatever speed it is, it's moving with the same speed. Right. So it just means that it's moving with the same speed. Now, this going up, it means that it's moving with uniform velocity. So a straight line like this represents object at rest for distance time graph, constant speed, and here it again represents that the acceleration is not there. So let's say time goes on, acceleration is 0, 0, let's say 10, 10, 10, 10. What is acceleration? Change in velocity by time. So change in velocity is constant. Okay? So that means it's moving with a constant acceleration. And then increase in acceleration, deceleration. You actually don't need acceleration time graph. Velocity time and distance time will do. Okay? That is more than enough for your KCET. Now, one very important thing is, sometimes they will give you a velocity time graph. Okay? Let's say this is a velocity time graph and they'll ask you to find out displacement. So, when you to find out displacement from a velocity time graph, what should you do? You should find out the area under the graph. Okay? So, very important. Area under velocity time graph gives displacement. So, in this case, it will be length into breadth. So, in this case, what will I do? I will divide it into two triangles and do half BH plus half BH. Okay? So, area under velocity time graph gives you displacement. The difference between acceleration and velocity time graph is, here acceleration represents change in velocity. Velocity represents it's like speed, but you don't want acceleration time graph. Velocity time graph is more than enough. Okay, because you will get confused between the two. Is this much clear? Can I have some fire emojis in the chat, students? Clear? I'm breaking the ice. I'm going from very easy portion to more difficult portions. Alright. Okay. Now, Next is equations of motions. You might have definitely, your teachers might have made you study these equations of motion in your PU, but since you did it in your first PU, we'll revise. First one, V is equal to U plus AT. What is V? Final velocity. U is initial velocity. A is acceleration. T is time. So let's say I'm initially at rest. Okay, I am in my car. I haven't started my car. What is my initial acceleration? 0, because I have not started my car. And then I start my car. I start driving. Now my speed is 5. So V is 5. U was 0 because initially it was 0. And then acceleration is how much my speed changes. Time is how much time I take. Okay. Now, second equation of motion, S is equal to ut plus half at square. S is distance or displacement. Okay. So the displacement is ut plus half at square. Third equation of motion, V square equals U square plus 2as. Now, in all of these equations, I can modify them if my object is freely falling. Okay. So for your exam, say the question says, a ball is dropped from the top of a 10-story building. You have to find out something, velocity, acceleration, time, you have to find out something. Okay. So when a ball is dropped from the top of a building, it just falls down freely. So for anything that falls down freely, acceleration is equal to gravity. Okay. So that is how you can modify the equations like this. So everywhere, wherever there was A, it becomes G. When is it becoming G? It becomes G when something is freely falling. For example, I have this pen, I'm just dropping it. So when it falls freely, it is accelerating down only because of gravity. So in that case, acceleration becomes G. But when I'm driving a car, I am accelerating. So when I'm accelerating, that acceleration is A only. That is not because of gravity. So when something is freely falling, when there is free fall, acceleration becomes G. Now when does G become positive? When does G become negative? So when something is falling down, it's falling towards gravity. So gravity does not have to resist it. So in that case, G is positive. But when I'm throwing this up, when I'm throwing something up, I am going against gravity. At that time, gravity becomes negative. So you have to change your equation of motion depending on all this. You have to check if it's freely falling. If it's falling, is it falling upwards or downwards? Depending on that, the value of gravity will change. Okay? Is this fine, Ritu? Alright, is this much clear? Okay. Now, next one. This is the distance traveled in the nth second. Okay. So, let's say you have to find out the distance at 5th second. So, I'm saying my pen is falling down. Okay. After 5 seconds, I have to find out the displacement. In that case, this will be my formula. Okay. So I have an example here. So U is equal to 5, A is equal to 2. Find the distance in the 4th second. So what will my n be? My n will be 4. So it will be 5 plus 2 by 2 times 2 into 4 minus 1. All of those is fine. You just have substituted n as 4. Acceleration is 2, U is 5. Everything else is given. So even if you don't have final velocity, you can do it. You will not have final velocity, right? Because you have to find out that. You have to find out the distance. So when can you use this formula? This formula you can use when you have to find out the distance something reaches in a particular value. Like, like this question. Say a person is running. Find out the distance he travels in 10 seconds. But his final velocity is not given. So in all the equations of motion, you need V, right? Except for S is equal to U plus half at square. So in that case, instead of F for finding out the time, you can use this formula. Okay? Is this fine? So when do you use this formula? When you have to find out the time at nth second. Okay? Okay, let's move on to the next question. So this is all that you need in motion in a straight line. What all do you need to know? Equations of motion, how they vary with respect to gravity. If you want to find out the distance traveled in one particular second, like 10 seconds or 5 seconds, you have to put it as n, this formula. Okay? What else? Yeah, all the velocity time graphs, displacement time graphs, and to find out displacement, you have to find out area under graph. Okay? Is this all fine? Motion in a straight line is done. Can I have some fires for all of you who understood motion in a straight line? Quickly, students, quickly. Can I have some fire? Then we'll move on to the next chapter. See, 2 chapters already done. Motion in a plane. Now, for motion in a plane, the most important thing is projectile motion. You might have definitely seen, you might have practiced some questions, right? You might have seen a lot of projectile motion. So, what is projectile motion? I have, let's say, javelin throw. Okay? I'm taking a javelin, I'm throwing it. How does the javelin go? It takes a projectile motion. So, it is moving like this. Okay? So, that is projectile motion. So, for projectile motion, there are only 4 formulas that you need to know. I'm not sure if it's 4. Don't kill me if it's not 4. Only the formulas you need to know. No steps, no derivation, nothing. Okay? So, the path of a projectile is always a parabola. And the main formulas that you need to know is the time taken for the projectile. T is equal to 2u sine theta by g. Okay? Quickly, all of you learn that formula. Time of flight. The time taken for a parabola, for a object, take a parabolic path, which is a projectile path. T is equal to 2u sine theta by g. Okay. Now, height of a projectile, u square sine square theta by 2g. Another very important formula. Range of a projectile, u square sine 2 theta by g. Okay. These are all main things in projectile. Now, some main other things in projectile is that the maximum range is when theta is 45 degrees. So this was there in one of the previous year papers. The question was, find out the value of range when it was maximum. So you should know that theta has to be 45 because that will not be given to you in the question. So maximum range, what does maximum range mean? So it means, so the parabola can reach here, it can reach here, it can even reach here. So the maximum range is when it reaches here. And it reaches here if it is launched at an angle equal to 45 degree. If it's less than or more than, it wouldn't travel to the maximum. So maximum range is when theta is 45. Okay? And the time to reach maximum height, see, this is the height of the projectile. The time to reach maximum height is t by 2. Okay? Now, the projectile along the horizontal direction, okay, so if it's moving like this, along this direction, the horizontal direction, there is no acceleration. See, this is a freely falling body. Will anything accelerate it forward? There's only acceleration downwards, that is because of gravity. So the acceleration is in the vertical direction and that is because of gravity. In the horizontal direction, there is no acceleration. It is just moving because of the force that we applied when we launched it. Okay? Is that clear? That's all that you need to know about projectiles. What all you need to know? Range formula, height formula, time of flight formula, path of projectile also you can learn. I've not seen any questions related to that, but you can learn that. Time, range, height, very important. Alright? And the maximum angle is 45 degree. That's when the range is the maximum. Okay? Okay. Next one that you need to know in this chapter is uniform circular motion. So, when is something in uniform circular motion? When it is moving in a circular motion with an angular velocity. So, what is normal velocity is when you move in a straight path. When you move in a circular path, the velocity becomes angular velocity and it is represented by omega. Okay? Now, let's look at each one of these. Yeah. So, angular velocity is d theta by dt. So, this is, see, angular velocity is when something is moving in a circular path. So, obviously, the angle is very important. How much the angle changes in a certain amount of time is angular velocity. Now, what is acceleration? You differentiate the velocity, you get acceleration. So, if velocity is d theta by dt, acceleration is d square theta by dt. Now, what is d square theta by dt? It is the same as omega being differentiated. d omega by dt. Does this make sense to you? Omega is d theta by dt, which is velocity, angular velocity. Now, if you differentiate this whole thing, d omega by dt is equal to d square by dt square. Both of these will give you acceleration. Now, linear velocity is the product of angular velocity with radius. Okay? How can you remember that? So, angular velocity is when something is moving in a circle. Sorry. Angular velocity is when something is moving in a circular path. Linear velocity is when something is moving in a circular path but with a radius. Linear means straight. So straight is radius. So angular with radius is linear. This is just a shortcut for you to remember. Okay. So angular with a straight part which is radius gives you linear velocity v. So what is linear acceleration then? Linear acceleration is v square by r, which is also the same as omega square r. So acceleration is always towards the center. Now, when something is moving in a circular path, the only force that makes it move in a circular path is the centripetal force. So, what is centripetal force? So, if you have a circle and let's say, okay, what should we? Let's say you have the earth. Okay, the earth is moving in a circular path. Why does the earth move only in that path? Because it has a centripetal force always acting towards the center. And the centripetal force is given by mv square by r. Okay? It's also given by m omega square r because v square by r is the same as omega square r. We already learned that. Okay? So centripetal force is the force towards the center. Now, just like we learned the kinematic equations, right? The equations of motion, here we will learn the equations of angular motion. So, one chapter, when you learn that, you have to use it for other chapters as well. So, here we will look at angular motion, kinematic equations for angular motion. So, earlier it was kinematic equations for normal linear motion. So, just like you have v is equal to u plus at, here you have omega equals omega naught plus alpha t. Acceleration is alpha, u is omega naught, v is omega. Now, you have one more equation for kinematics. Omega square minus omega naught square is equal to 2 alpha theta. This is v square minus u square is equal to 2 as. Now, here s is the distance. Here the distance is not straight. It's at an angle. That's why there is theta. A is acceleration, which is similar to alpha. Is this clear? So, this is circular motion. These are some formulas that you need to know for circular motion. It will be difficult for you to by heart to relate and study. Okay. So, what is velocity? Distance by time. So, what is angular velocity? Distance here is an angle. So, d theta by dt. So, instead of ds, which is the distance, you put d theta by dt. And then you differentiate it, you get acceleration. Okay. To find out linear velocity, v is omega times the radius element, which is the length element. Okay. And then you can actually compare. That's why I explained it to you comparing. So, if you know what is v, what is u, what is a in the angular regime, you can just substitute. Is that fine? This is clear. Can you all put some fires in the chat? Or can you say okay? Or you can say you're good. Oh, why did I rub that? When I send this to you as notes, it's good if it's there. U plus at, v square minus u square is equal to 2as. Okay. Next is laws of motion. So that's the end of this chapter. We're going on to the next chapter. Is this clear to everybody? 3 chapters done. Quickly, let me know in the chats. Okay. Next is the laws of motion. So in laws of motion, the main thing that you need to know is how your weight changes in a lift. So imagine you are inside a lift and you are moving up and you are moving down. So if you are moving up, what happens? You are going against gravity. So your force will be mass. F is basically ma. But you have to add gravity as well because you are moving against the gravity. So it becomes F is equal to mg plus a. Now if you are coming down, you're along with the effect of gravity. So you can actually remove the gravity from your force. So it will be g minus a because your acceleration is already because of gravity. So you can subtract it off. So if you're moving up, you have to add gravity. If you're coming down, you have to subtract gravity because you're going along with gravity. You don't have to separately add it. Now, when do you feel weightlessness? So apparent weight basically is zero weight or weightlessness. Weightlessness is when the lift is freely falling. Both the lift and the person, they fall with the same acceleration when there is no force. Okay. So when something is freely falling, that's called weightlessness. So 3 things. When acceleration is moving upwards, gravity you have to add. Coming down, gravity you have to subtract. when there is no gravity, there's gravity, but something is freely falling, it's weightless. Okay, so force is basically 0. Okay, next is friction. What is friction? Okay, friction is basically F is equal to mu n. So the coefficient of friction is mu and it depends on the different materials that are in contact. Okay, and mu is tan theta. So if there's friction at an angle, let's say there's an object or a block here and this is coming down at an angle. So this angle will be your theta. Next is motion on an inclined plane. So what is motion on an inclined plane? So to just start moving, so as I said, there's a slope, there's an object here. This object can slide down or stay here depending on the friction of the surface. So what are the forces acting on it? So the first force, okay, let me just draw that here. So if this is the object, the first force acting on it is its mass times gravity downwards. The second force acting on it is obviously normal reaction force in the opposite direction. Okay, and then there is friction also acting on it. But this mg, you can see is at an angle, it's not at 90 degrees. So you resolve mg into a horizontal component and vertical component. Okay, you make it into two. You make mg between two perpendicular components. Those are your mg sine theta and your mg cos theta. So if you want to move up the incline, so what should your force be? It should be mg sine theta, which is this component, mg sine theta plus friction, which is mu cos theta. So if you want to move up the incline. Now if you want to slide down, what happens? Friction, if there is friction, you just do mg cos theta minus mu sine theta. Alright. These are all formulas, the derivations you have learnt in your PU. If I do the derivations, it will take a lot of time. So I'm not going through the derivations, but the formulas we will see. Now acceleration on an inclined plane, if this block has to accelerate down, it is basically g sine theta minus mu cos theta. The mu cos theta term is friction. So if there is no friction, it becomes only g sine theta. Okay. So acceleration will be g sine theta. So if for exam, they can give you diagrams like this and ask you to evaluate force and acceleration. Alright. Okay. Students, if you all are watching this, can you all go hit the like button and come back? Go smash the like button and then come back. Okay. Alright. So what else? Now friction. This friction, it can either make the block stay there or it can make the block slide down. So if the friction is very high, the block wouldn't slide down. So if the friction is greater than mg sine theta, then the block will stay there. If the friction is less than mg sine theta, then the block mg sine theta is strong, so it can come down. Okay. Next is very easy for bodies in contact. So imagine you have M1, M2, M3 in contact. If I apply a force on the first one, the force is going to be transferred to all three. So how will I find out the combined force on all three? So the combined force will be M1 plus M2 plus M3 into A. So A would be F by M1 plus M2. Okay, do you understand this? I have three blocks and I push it. So the acceleration of the three blocks will be total mass into acceleration. Okay. Now if I want to find out the force F1 here. So F is the first block, force on the first block, which is going to be affected to all three blocks. Now on the second block, it will have a force F1, which is going to act on the third block. So that will be M2 plus M3 by A only, because the first F1 is after the first block. Now if I want to find out the force on the third block, I have to only consider the mass of the third block. For all, I have to consider all three. So just some basic logic. Okay. So the total F is equal to ma. If I have three masses, F is m1, m2, m3, a. Acceleration is F by m. Okay. Alright. Next is for a pulley. For a pulley also, you don't have to learn any complicated things. You have to learn only the formulas. So how will you learn the formulas for a pulley? Okay. For pulley, you only have to know so what is happening on a pulley. You have two masses. Okay. And the masses are balanced depending on the amount, their value. Okay. Another important thing you need to know, whenever you represent tension, what is tension? Tension is the force on the string. Tension is always away from the mass. Okay. So if the mass is downwards, tension is upwards. If the mass is towards the right, tension is towards the left. So tension will always be in the opposite direction. Downward force will always be M into G. Okay. So now for a pulley, the acceleration is given by m2 minus m1g divided by m1 plus m2. Tension is 2m1 m2g divided by m1 plus m2. Now, separately if you want to find out the tension, so you have two masses, okay? Let's say mass m1 is going up, which means it is lighter. So when it is going up, the tension experienced by that mass will be its mass into its going up, similar to the lift. So when a lift is going up, what happens? It is G plus A because it's going against gravity. So this is the same thing. Tension is just force. Force is mass into acceleration. So here, instead of acceleration, you put A plus G. Now if it is coming down, what happens? It's along gravity. So you subtract G. Okay. Maitri, I've done MCQs. There is a video. You can go check that. First PU MCQs are already done. This is a class for theory. Okay. Yeah. Next is when pulley with one mass is hanging and the other is on a table. So something like this. When there is one mass hanging, one mass on the table. So what happens? In this case also you can see. So if the mass is along this direction, tension is in the opposite. If the mass is downwards, tension is in the opposite. Same formulas, but here only one mass is there at a time. So acceleration is equal to m2g. In the previous case, there was m2 minus m1g because the effect was for two masses. Okay. Same thing for an active machine as well. Okay. Next is circular motion or banking of roads. Okay. So why do you need banking of roads? What is banking? Banking is if you have a curved road, okay? If you have a curved road, if you just go on it straight, the car might skid. So what they will do is, this curved road, they lift it a little. So the road was like this, they lift it a little, they make it at an angle. So the advantage of making it at an angle is that you'll be able to balance if you're going at very high speeds. Have you seen these racing tracks? For Formula 1 races and all, the racing tracks are always like this. They are not like this. They're always like this. That's because cars are at very high speed. So only if the roads are banked, they will not skid. Okay. So yeah. So key things that you need to know here. Formulas. Important formulas for speed. What is the formula for speed? The maximum velocity that the car can take without friction and without hitting anywhere is Rg tan theta plus nu 1 minus nu tan theta. Nu is your friction term, tan theta is the angle at which you are bending the road, R is the radius of the truck. Okay? Now, that is a important thing. Yeah, this is for banking of road. Now, see, what is centripetal force? I already mentioned. It's when something is moving to the center. There's force towards the center. Now, whenever your frictional force is greater than or equal to your centripetal force, then it's balanced. So what is friction? Mu mg. So mu mg should be greater than mv square by r. So you cancel, you get v is equal to mu rg. V max is equal to square root of mu rg. So what is that? The maximum velocity by which the car can move is mu rg. Okay? Is this fine? All these, the concepts you've done in your first PU. So some important things to remember. Banking reduces friction so it becomes safer for higher speeds. And you have to know to convert kilometer per hour to meter per second. You just have to divide by 3.6. And common questions are to find theta, to find out speed, or why roads are banned, things like that. Okay. Next chapter, we're done with that chapter as well. Next chapter is work energy power. Okay. So work energy power. Is this much clear to all of you? Can you put some fire emojis in the chat if this is clear? Yes, crazy boy. Crazy boy is studying also among all these chit chats in the chat. Okay. Next is work energy power. So work energy power, first formula, the most important formula, work done. What is work done? You only say work is done when you apply a force and the object moves by a distance. Okay. So if you simply, if I keep pushing the wall, I'm not going to do any work because the wall is not moving. Work is done only when if I push the wall and the wall moves. Okay, maybe if I'm Hulk or something, I can do that. So when I push the wall and the wall moves, that's when work is done. That is why the formula is force into distance. Okay, so it is F dot S. So when you expand it, it becomes F dot X cos theta. So there is an angle as well. So if you apply a force and a distance is moved at an angle, that's when work is done. Now kinetic energy is half mv square. That can also be written in terms of momentum as p square by 2m. There are two kinds of potential energy, gravitational potential energy and elastic potential energy. Gravitational potential energy is mgh. So it changes with height. So in some questions they might ask you what happens when height increases. Gravitational potential energy will increase. So mgh, h is height. Elastic potential energy is mainly for springs, spring constant and all that. When you expand a spring, what happens? It has elastic potential energy. That energy is half k x square. Okay, so k here is spring constant. Next, very important theorem, work energy theorem. What does work energy theorem says? That whenever I do work, it means that I am transferring some energy. Right. When I'm doing work, obviously some energy is transferred. So that means change in energy is the same as work done. Now what is change in energy? Energy is half mv square. So change in energy is half m. No, change in energy is kinetic energy, final kinetic energy minus initial kinetic energy, which is half mv square minus half mu square. So this is the same as work done. Work done is what? F into S. So that is work energy theorem. Change in kinetic energy is the same as work done. Now, the rate of doing work. See, whenever the word rate of comes, it means divided by T. In any question, if rate of is there, it means divided by T. So, rate of doing work is W by T. What is W? Force into displacement. S is not speed, displacement by T. Now, what is displacement by time? Velocity. So, P would be F into V. Okay, S by T, this is speed. So, P is F into V. Okay. Alright. Next is collision. There are two kinds of collisions. When something goes and hits on something else, it becomes a collision. There are two kinds of collisions, elastic collision and inelastic collision. So, elastic collision is where what happens? We have two bodies. These two masses hit against each other and then they go their separate ways. Momentum and energy both are conserved. Okay, so that means if this one had a momentum of m1 u1, this one had a momentum of m2 u2, and these two hit together. Now they go by their own, they go separately. They will still have the same momentum. Okay, energy is also conserved. That means you can see the energy when you add the energies of m1 and m2 on one side. It is equal to the energies of m1 and m2 after collision. So whenever energy and momentum are conserved, then it's called an elastic collision. But what is an inelastic collision? Inelastic collision is when you have two masses, they hit and then they go together. They're like, so many people who are in love in the chat. They go together. So, but when they go together, they're missing out something. See, just like when you're spamming in the chat, you're missing a lot of important concept. So, when they go together, here what they miss is they lose energy because they have to go together. So, in inelastic collision, energy is lost, but momentum is conserved. Alright. So, what is the formula? M1 M2 plus M2 U2 equals M1 plus M2 into V. M1 plus M2 because it becomes 1. After they hit, they are 1. Nobody can separate them. Okay? The momentum is conserved but energy is lost. And the value of the energy loss is given by half into M1 M2 blah blah blah. This one. Alright? Okay. Let's move on to the next topic, which is coefficient of restitution. So coefficient of restitution is basically E. Okay. It is the speed after collision divided by speed before collision. So after collision it moves, right? The speed by which it moves and the speed by which it moves before collision. Now, if the coefficient of restitution is 1, that means it is before and after the speeds are the same, perfectly elastic collision. If it's equal to 0, it's not moving, perfectly inelastic, but both of these never happen. So real collisions will always have values between 1 and 0 because no collision is perfectly elastic or perfectly inelastic since we don't live in an ideal world. Alright? That is also done. Next chapter. So these are the only things that you need to do for this chapter. You need to know about inelastic collision, what all happens, and the formulas. Elastic collision, not all formulas for V1, V2, and then whatever is conserved. That's all. And then formulas for work done, power, kinetic energy. That's all that you need to know from this chapter. See, very little portion from each chapter. I'm doing only the important chapters. Important portions where I have seen questions from. Alright? Okay? So can you all, in this class only revision, yes. I already have MCQ done. You can go check the videos, it's there. Okay? Is this fine? Can we go to the next chapter? System of particles and rigid bodies. Quickly students, can I have some thumbs up? Okay, cool, good to go. Something in the chat? Yes. Ajay wants to know if everybody finished their KCT preparations. Have you finished, Ajay? Okay. Next topic is system of particles and rigid body. So here the main important thing you need to know is center of mass. So what is center of mass? So for example, you have two masses. Okay, the center of mass point is here where the masses contribute equally. Okay, so now if you want to find out the position here, what you will do? You will do M1 into R1 plus M2 into R2 plus how many ever particles are there. Since here you have only two particles, M1 R1 plus M2 R2 divided by M1 plus M2. Now if you want to find out the X coordinate and the Y coordinate, you will take the X value and the Y value. So it would be M1 X1 plus M2 X2 by M1 plus M2 for X coordinate. Now if I want to make this a Y coordinate, what will I do? I will erase this X. You don't erase, you write it once again. So if you want to find out Y coordinate, I will put it as Y. Okay, so this will give you the X and Y coordinates of your center of mass. Center of mass is a position where all the masses act on it equal. Ajay, I will try. Okay, I'm not going to promise you because you hardly have 3 days, right? I will try. All right. Tarun, you're distracting so many people, it seems. Okay, let's not waste time. We're focused KCT aspects. Now, velocity of the center of mass is how? So instead of X, for X coordinate and Y coordinate, I put X. So instead of that, for velocity, what I will do? I will put Y. So that's all, simple, not Y, V. Okay. So for X coordinate, I put X there. For Y coordinate, I put Y there. For velocity, I'm going to put V there. Now, if you want to find acceleration, I will change this to A. Very easy. So now I have for position, what did I do? I will change this to R. So I have the position, X coordinate, Y coordinate, velocity and acceleration for center of mass. Okay. So M1, whatever it is, plus M2, whatever it is, by M1 plus M2. Now, if there are 3 masses, you have to do M3 also. For masses M4, it just goes on like that. Next, moment of inertia. Now, what is moment of inertia? Moment of inertia is how the mass is distributed with respect to one axis. So, if I have a body and it's rotating along this axis, how the mass is distributed along this axis is my moment of inertia, and moment of inertia is given by the formula I is equal to mr square. How will we remember this? Just like mv square, mr square. Okay. Now if I have 5 masses, okay, it will become m r1 square, m2 r2 square, n3 r3 square, it goes on. If all the masses are the same but there are different distances, m, r1, r2, r3, r4, each square. Okay, so for a single particle, I is m r square. They might ask question based on center of mass as well. Again, I've only taken most important topics. You need to know center of mass of various objects. I'll show you. Next is the radius of gyration. Fancy name, no? Just a second. Okay. Radius of gyration. It is the distance from the axis. If this is the axis, the distance from the axis at which the mass is concentrated. So imagine I have a mass here. This is the axis where the center of mass is. This distance is called radius of gyration. Okay. So radius of gyration is given by the alphabet K. So K is obviously the distances, right? So the square root of all the distances divided by how many ever distances are there. So moment of inertia can also be written in terms of radius of gyration. It can be written as mk square. So this k is not spring constant. So in spring constant also we have a k. Radius of gyration also there is a k. So I is equal to mk square. Is this fine? Okay. So radius of gyration is the distance from a mass to the axis. Inertia is the distance where all the masses are concentrated. Now parallel axis theorem, perpendicular axis theorem, I think it's removed from your syllabus, right? Can you just confirm? I saw it as deleted. So parallel axis theorem is very simple. You have a line of center of mass. You have to find out the inertia at some other line. Okay, so this is my center of mass. So I have to find out the inertia at some distance here. So the distance between the line and the center of mass is r. So along this line I have to find out inertia. So what will my formula be? Along this line my inertia will be inertia of center of mass plus m into r square. What is r? The distance. Okay, what is m? My mass. Okay, now for perpendicular axis theorem, you take all 3 axes. Now if you're along the z-axis, the moment of inertia will be, you just sum the other 2 axes. That's all. Okay, if you take y, you sum z and x. So here, if you have, so see, so how will questions come here? So they will ask you you have to find out the moment of inertia along this distance. You have to take that particular line and measure r. You don't have to measure, it will be given to you. Now this is also important. You need to know which all shapes have what all center of mass. Not every, but the ones that I've ticked. Okay. So if you have a hollow hoop, I is mr square. Now if it's a solid cylinder, it will become mr square by 2. So it was only mr square. So when the ring got elongated as a cylinder, you divided by 2. Now, if the cylinder now has a length of L, it becomes ml square by 12. Okay. And then this is 2mr square by 5, imr square by 2, all of that. Okay. Next is motion of a rolling body on an inclined plane. Okay. So for a rolling body, so take the same figure. This is a dirty figure because, so there is a sphere and this sphere is rolling on an inclined plane. So what are the two motions there? There is rotational motion because the sphere is rolling down. There is also translational motion downwards. Okay, it's moving straight. Translation motion. It's also rotating and going down. So this is rotational motion. So you have to remember the value for formula, the formula for kinetic energy, velocity and time as well as acceleration for this one. So for those of you who can't by heart the formula, you will have to derive it and learn, but you can't derive it for your exam. So the only option is to remember your formulas. Okay. Why are you scared, Ajay? This is not do or die. It's just KCT. Okay. Okay. So my class was like an eye opener to all of you. You got to know so many questions are there. You're all planning to quit or what? Look at the formulas, pick whatever you can and finish that. Because see, sometimes you can get lucky. You might get question from what you learn. Let's see that you can test your luck. So don't stress out. Whatever you learn properly. Okay. Don't just learn everything and forget everything. Whatever you learn properly. So whenever you have a body that's rolling, it has translation motion and rotational motion. So that is why, okay, for kinetic energy, I'll tell you how kinetic energy came. Kinetic energy is half mv square because it's moving straight down. It's half I omega square because it's rotating as well. For V, T and A, you should learn it. Okay? Now, yeah. Total kinetic energy of a rolling body is half mv square plus half I omega square, right? Now, what was omega? We had already learned that omega was V by R. So now, if it is a solid sphere, if you have a solid sphere, here we learned. See, for a solid sphere, the formula is I equals to mr square by 5. So, instead of I will substitute 2m r square by 5, but instead of that I will put v square because omega is v by r. So I will get 7 by 10 mv square. So this is how you find kinetic energy of different bodies. You need to know the value of inertia for different bodies. Not for all, for most of the ones that I've ticked. So primarily you learn these two, these, yeah, and then these. This one row, if it would be good if you can learn this one row. Where do you use them to find out kinetic energy, or wherever you have I? Okay, you can substitute those values because I will change from body to body. Is this clear? Is this clear? Prabhavati, I just think it's genetics. Alright. Yeah, so see, so many different shapes. I has so many different values. You will get different values for kinetic energy as well. Okay. Did you all like the video? So here what you have to do is you have to remember A, B and T. So done. This chapter is done. Can I have some fire emojis? Some appreciation for all of us. We finished one more chapter. Can you all clap in the chat? You smashed? Ananda smashed the like button. Sakshi also. Okay, so in this chapter, what all do you have to know? You have to know kinetic energy of a rolling body, acceleration of a rolling body, velocity of a rolling body, time of a rolling body, and then different values of inertia. Now, what is inertia? Inertia is mr square. This is only for one general formula, but depending on shapes, the value of inertia will change. That's all that you need to know from system of particles. Okay? I will try. Okay, Ritu, I'll try. Okay? Clap, clap. Shall we all clap? We finished so many chapters. Now we have only a few more chapters left. Next is gravitation. Gravitation is a chapter that you will all like. Oh, it's not that complicated. Formulas are also not that complicated. Nobody is clapping. Habib. Thank you, Habib. Yeah, you applaud for yourself. Okay, so first thing, universal gravitational constant, which is Newton's law of gravitation. So if you have two masses, there is a force between them, and that force depends on the weight of these two masses and the radius between them. So that is how you get F is equal to Gm1 m2 by r square. You have two masses. This mass is m1, this mass is m2. The distance between them is r, so they have a force acting on them. Now this force is proportional to m1 m2 by r. So when you remove the proportionality, you get a constant. You have to remember the formula for G. I mean the value of G, 6.67 into 10 raised to minus 11. It will not be given to you. Okay. I will give you this PDF that I am sharing now. I will give that to you. It will be there in the description box of the YouTube video. Okay. You can go just check after the class. Not now, after the class. Now it won't be there. Alright. So you have to know the value of gravitational constant as well. Okay. Yeah. Yes. Okay, next. Next is the formula of acceleration due to gravity. So from your childhood, from whenever you started learning physics, you have been learning gravity is 9.8 or gravity is 10. So that gravity is small g. It is not big G. The big G that we learned is universal gravitational constant. That is different. So this small g is capital letter G into m divided by r square. So this r is the radius of the earth. Okay. R is the radius of the earth. G is universal gravitational constant. M is mass of the earth. M is a big value, mass of the earth. Okay. Slayers clapping in all possible colors. Okay. So, yeah. Now we will learn most important thing in gravitation chapter, how gravity changes with height and depth. Okay. So your PU teachers might have made you learn this last year, but you might have forgotten. So let's revise. So first thing, you have the earth. You want to find out the gravity at a point above the earth, which is at a height h. Okay. R is the radius of the earth. So what is the formula? G dash, which is the gravity at a point height above the earth, is G, which is the gravity on the surface of the earth, divided by 1 plus h by r square. H is the height at which you are finding gravity. R is the radius. So it will definitely be less than 10. As you go up, gravity will reduce. Now this formula can also be rearranged as G dash is equal to G into 1 minus 2h by r. You need to learn both. You can just learn one and from that you can get the other also, but you need to learn both. Okay. Next is at a depth. So what happens? You are inside the earth. So on the surface gravity is 10, but at a point you dig a hole. Okay, you dig a long hole, and when you reach the end of the hole, you want to find out the gravity there. So that you have to use this formula. G dash is the gravity at a depth. It will be G into 1 minus d by r. Okay. Now at depth is 2 times height. So if your depth is 2 times your height, at that one particular value, the gravity will be equal on top and at the bottom. So as I said, on the surface gravity is 10, it keeps reducing. So at one point on top and at one point at the bottom, they will have the same gravity, and that point is d equals 2h. So the depth will be 2 times the height. So this is important. I've seen a question where they ask this, at what height it is. So d is equal to 2 by h. 2h. You'll actually get this if you add the formulas for gravity at a height and gravity at a depth. But you don't have to do all that. You can just remember at d is equal to 2h. Gravity is same on top of the earth and at the bottom of the earth. Okay. Next is gravitational field. So gravitational field is F by m, gmm. What is F? Gmm by r square. So I will be gm by r square. This is gravitational field. Okay. Next is gravitational field due to a solid sphere. So this we've learned in electrostatics and potential as well. So if you have a sphere, okay, and this sphere has a radius. So inside you can see the gravity is proportional to r. Outside you can see the gravity is proportional to 1 by r square. So it's reducing. And the point on the surface is r equals r. So you can look at this. So when r is less than r, okay, so when r is less than r, I is gm by r square. When r is equal to r also, it's gm by r square. But when r sorry, first one is R greater than R, I'm sorry. So when R is less than R, I is GM R by R cube. Okay? Alright? So this is how gravitational field varies with a solid sphere. You can just remember with the graph. Next is gravitational potential energy. What is potential energy? Gmm by R plus H. Or you can write it as mgr by 1 plus H by R. All these formulas you might have learned. I'm just revising the formulas. If I explain how all these are derived, I will not finish my class today. I'll have to take like 2 days of full class if I do derivations of all chapters. Okay, next is the Kepler's laws of motion. What is the first law? Planets move in elliptical orbits with sun as the foci. Law number 1. Second law. So, every planet sweeps out equal areas in equal intervals of time. And law 3 is T square is proportional to A cube, which means the time period by which a planet moves is proportional to the cube of the semi-major axis. So, if this is your ellipse, so this the cube of the semi-major axis. So, these are the 3 Kepler's laws. Okay, next is satellites, types of satellites. There are 2 kinds of satellites, geostationary satellites and polar satellites. Okay, where is my cursor? Okay, yeah, here. So, geostationary satellites and polar satellites. What are geostationary satellites? They are at a height of around 36,000 kilometers from the Earth's surface. And they have an orbital period of 24 hours. So, they take 20, meaning they will orbit the Earth every day. So, in every 24 hours, they can orbit around the Earth. So, it's like if you go on a trip on a geostationary satellite, every day you can round the Earth. Okay, because in 24 hours, they will finish one. And their velocity is 3.1 kilometers per second. Imagine how fast it is. In 1 second, it can travel 3 kilometers. In 1 second, we can't even travel 100 meters. Okay, so it's that fast. Okay. Break. I will give you a break after 10 minutes. Okay. Next is polar satellites. Polar satellites, they are at a lower height. So geostationary satellites are like at a very big height, 36,000, but polar satellites at a lower height, only like 800. So if this is the Earth, at 800 kilometers you have polar satellite, and at 36,000 kilometers you have geostationary satellites. Okay, and for polar satellites, the time period is 84 minutes, which means they take 1.4 hours to complete one orbit. And their velocity is 8 kilometers per second. Imagine how fast it is. In 8 kilometers, it will move. But geostationary takes 3 kilometers for 1 second. Here they cover 8 kilometers in 1 second. So that's the difference between geostationary and polar satellites. You also need to know the formula for time period of satellite. It is 2 pi by r plus h the whole cube by g. Okay? H is less than r when it is near the surface. What is h? H is the height above the earth. It is very close to r. Alright, so t is also equal to 2 pi square root of r by g. There are so many formulas, students. I know it's difficult, but if you just mug up, you will forget. So every formula at least 5 times you write and learn. So even if your mind forgets, at that time when you try to write it, you will be able to write it because there is something called as muscle memory. That's why people tell don't study maths and physics by reading. You have to write because your muscle memory will help you. So write and learn all these formulas. Okay. So next is the orbital velocity. What is orbital velocity? Orbital velocity is the minimum velocity that is required to put a satellite in orbit. Okay. So if a satellite has a velocity v0 and that is gm by r, with that velocity it can go up to the orbit. Otherwise it cannot escape the Earth's atmosphere if it's not fast. See, that's why rockets go fast. If a rocket slowly goes, it will be stuck inside Earth. It cannot escape out. So only if the velocity is very high that it can escape out into the space. That's what is orbital velocity. Okay. Yes, layer. So r is equal to square root of r by r plus g is also another formula for radius. Next is the energy of a satellite. Energy of a satellite is Kinetic energy plus potential energy. How much is kinetic energy? Gmm by 2r. Potential energy is gmm by r. If you do the math, you will get gmm by 2r. Escape velocity is also the velocity that is required to escape from the Earth's surface. So that is 2gm by r. Okay? Is this much clear? Fine? Did you all go like the video? All of you please go like the video and come back. Okay, so that's all. Gravitation is done. Claps. Claps to us. So in this chapter, what all do we have to learn? We have to learn universal gravitational constant formula, relation between small g and big G, then the formula for gravity at an altitude, gravity at a depth. Then formula for gravitational field due to sphere, formula for potential energy, Kepler's laws, the two types of satellites, time period, orbital velocity, energy and escape velocity. Okay? So these are the things that you need to learn in this chapter. Is this clear? Okay, so before mechanical properties, do you need a break? Okay, quickly we will have a small break. Resume back at 8:40. Okay? Yes, Ajay, notes of this section I will give after the class. It will be there in the description box. Okay? Yeah. I'll see you all at 8:40. You can all quickly go eat something and come and drink some water. Hello students, welcome back. Are you all back? If you are all back, can you put some fire emojis? Okay? Okay, so let's continue with our one short power pack revision of first PU. So we're back. So let's resume back. Okay, are you all back? Full energy? Can I have some fire in the chat so we can start with full energy? Next, we're going to look at mechanical properties of solids. Yes, Ajay, I will try, but I won't promise you because we only have 3 more days. No? Let's see. Okay, Renuka, Dikshita, Gagana, Om, Ritu, all of you back. Yes. How's your preparation going? All of your preparations going well? I saw your message, Ajay. You don't have to keep sending it again. Okay. Let's start with mechanical properties of solids. So in mechanical properties of solids, the first thing you need to know is these terms. What is elasticity? What is plasticity? What is stress? What is strain? What is elasticity? If I have an elastic spring, I can stretch it. The moment I leave my hand, it comes back to its original shape and size. Right? So that is elasticity. Okay? Just a second, I'm just keeping my things properly. Okay? Now, what is plasticity? If I stretch let's say I stretch this pen, it will just break. It's not going to come back to its actual shape and size. So, this is plastic. Now, if I had a spring, I don't have a spring, so I can't show it to you. If I had a spring, the moment I leave my force, it comes back. So, that is elasticity. Next, what is stress? Stress is the force that I apply in a certain area. So, if I have my mouse, okay, and I apply a force on it, along the area of the mouse, that is stress. So then some of you might ask, pressure is also force by area. Then how do we know which one is stress, which one is pressure? Because both are force by area. So the hint there is stress is internal force. So if this is my hand, okay, and I'm applying stress, force by area, I'm applying it into the object. But where is pressure coming from? From inside, pressure is outward. Okay, so stress is internal force, pressure is outward force or external force. Both are force by area. So this can come. Okay, if this don't come, don't tell anything. But we're just predicting. All right. So pressure is force by area externally. Stress is force by area internally. Next is strain. Strain is basically the change in dimension by original dimension. What are the dimensions? Length, mass, and time. So if the length changes with respect to the original or mass or something changes, then that is called strain. Okay. These are the main important terms that you need to know. Yes, Anurag Krishna, Malayali. Okay. Next is longitudinal strain. So what is, as I said, what is strain? Strain is change in dimension by original dimension. So as I said, one dimension is length. So longitudinal strain is change in length by original length. Now what is lateral strain? Lateral strain is delta d by d, which is change in lateral dimension by original lateral dimension. Volumetric is change in volume divided by original volume. So 3 types of strain: longitudinal, lateral, volumetric. Okay. Elasticity, plasticity, stress, strain, longitudinal, lateral, volumetric. These many things we learned now. Now let's move on. Next is Poisson's ratio. What is Poisson's ratio? So Poisson's ratio is just basically lateral strain by longitudinal strain. What was lateral strain? Change in lateral dimension by original dimension. Longitudinal strain was change in original length by original length. Okay, this is Poisson's ratio. So Poisson's ratio is the ratio of 1 by 2, longitudinal by lateral. Sorry, 2 by 1, lateral by longitudinal. Next is Hooke's law. Hooke's law is also something that all of you will know. Okay, what is Hooke's law? Stress is proportional to strain. One definition I'm sure all of you by hearted in your PU. What is Hooke's law? Stress is proportional to strain. Okay, so you can use that in KCET also. So if stress is proportional to strain, if stress is proportional to strain, to remove the proportionality I have to add a constant. So the constant that I'm going to add is called Young's modulus, and Young's modulus is denoted by the alphabet Y. Okay, so stress by strain is going to be Young's modulus, which is Y. Okay, so stress by strain is Young's modulus. Now what is Hooke's law actually? If you look at the graph, you can see stress by strain, so stress is on the y-axis, strain is on the x-axis. You might have also learned to draw this graph in your PU, no? So you can see till point E, it's a straight line. What does that mean? So till point E, the moment I pull my spring and I leave my hand, it comes back to the original shape and size. But after that, if I apply more force, it does not. Have you seen springs that are no longer springs, right? So they will be, they'll be dead. So those kinds of springs are springs that have been given forces than how much it can take. Okay? So the moment you give more than E, it deforms and it becomes plastic. You learned what plastic is, right? Okay? Okay. Hooke's law is done. Yeah. So Young's modulus is also stress by strain. Stress is, as I said, force by area. Strain is change in length by original length. So Young's modulus can be written as FLA into del L as well. Another formula to remember. These are all very easy formulas to remember. So if you know what stress is and what strain is, you can remember this. So what is stress? Force by area. You can think of stress to pressure. Some of you, when I was a student, I used to get confused between stress and strain because both are similar words, right? So I used to remember stress as similar to pressure. What is stress? It's stressful. Just like you have pressure, stressful and pressure, both have the same formula, force by area. So the other one is strain. Strain is of three types. All those change in dimension and all that. Stress and pressure have the same formula and both have the same effect. So now all of you would be stressed under pressure. Yeah. Okay. Okay. Yeah. So now next is bulk modulus. So bulk modulus is for things that have, so let's say example, what example do I put? I take a stone, okay, anything, okay, I take a stone, I put it in water. So the stone experiences force from all directions because it's inside water, right? So that is bulk modulus, okay, when it has force from all possible sides. So normal stress by volumetric strain. So what is stress? Same as pressure, force by area. What is volumetric strain? Strain was of three types. First type was length by change in length by length. Second one was F by A, and third one was delta V by V. That is what we're using here. Okay. So bulk modulus is stress by normal stress, which is F by A divided by strain, volumetric strain. If it is the other one here, which one is it? Here it is. The three types of strain, we learned it here, no? So if it is longitudinal strain, you put del L by L, lateral strain, you put D by D, volumetric strain is V by V. Del V by V, I'm not saying del because you know it's del V by V. Is this fine? Now one last thing in this chapter that you need to know. Ma'am, stress is equal to stress, right ma'am? What does that mean? Okay, next is shear modulus. What do you want me to repeat, Tarun? Okay, shear modulus. Shear modulus is tangential stress by shearing strain. Stress is not equal to strain. Stress is proportional to strain. Stress is equal to Young's modulus into strain. That's Hooke's law. Okay? Okay, Ravi Kumar, you can see tomorrow, but please see tomorrow. Okay? And please like the video. All of you, all those who are here listening to the class, please go quickly like the video and come. Okay? So we know that you're all there. It's like an acknowledgement for us. Okay? So shear modulus. Shear modulus is tangential stress by shearing strain. What does that mean? So that means, okay, I have a block and I'm applying a force. This block is moving at an angle. How do I show it to you? Okay, this is a block. It's moving like this. Okay, it's not moving like this. It's moving like this. So it's moving at an angle. That is tangential stress by shearing strain. So that is shear modulus. So if I have a block, if I have a block, I'm applying a force and it is not moving like this, but it is moving like this. Okay? Alright? I'm not there on Instagram. My YouTube ID is Vedantu Karnataka. Okay, students? Done. Mechanical properties of solids is done. What all do you have to remember? Stress, strain, different types of strain, Poisson's ratio, Hooke's law, and then bulk modulus, shear modulus. That's all. Chapter done. Okay? So let's all clap for ourselves. One more chapter done. Very few more to go. In less than an hour, we will finish it. Claps. All of you put some claps in the chat. I will try, Ajay, because it's just 3 days, no? See, students, when you see this thing here, it's very easy, but preparing this material takes lots and lots of time. Okay, so that will take time. So that's why I'm not promising you if I get time to prepare the material, I will definitely do the class. Okay? Hello, Sarah. Okay, quickly. Oh, Soumya. Yes, I have all the videos, Soumya. I have first PU, but then all the questions that I have done are from past year KCET papers. Okay? I've done only KCET questions, but the concepts are going to be the same. But it's good if you can practice your past year papers as well. Thank you, Art World. Okay? So everybody liked the video? Everybody understood till now? Okay? Are you all good to go? Okay. Next is mechanical properties of fluids. So here we are going to talk about liquids. What is the difference between liquid and fluid? Anybody knows? Okay, that's your homework. Okay, you have to go find that out. So here we are going to talk about mechanical properties of fluids. First thing in this chapter is Pascal's law, the very famous Pascal's law. So what is Pascal's law? So the pressure exerted on a fluid is transmitted equally in all directions throughout the fluid. Okay, so if you have an enclosed fluid, okay, if you have a fluid and you apply a pressure here, it is going to be transmitted equally in all directions. Okay. Okay, Ananya, good night. Bye-bye. Okay, so what is Pascal's law states that the pressure exerted on a confined fluid is transmitted equally and undiminished in all directions. 20 to 25 marks you can expect from this. It depends. So what is that? The force by area will be equal to F2 by A2. An application of this one is the hydraulic lift. You might have all learnt, I don't know if you've learnt. So if you have the hydraulic lift, so one part, the area will be big, A1. This is going to be A2. Now if I apply small force F1 here it comes out as a big force F2. Why? Because pressure is the constant. Pressure is same throughout. And pressure is force by area. So force is pressure into area. Okay. So if I apply a force of 2 newtons, it would become, let's say, 10 into 5. Sorry. That was very stupid. I'm really sorry. So this is 50. Okay. 5 into 10. Yeah. So F1, A1. Now what happens? F2 will be how much? Let's say A2 is 1. It's a smaller area, right? A2 is, this is A2, A1, A2. Okay? So let's say, second students, correct. Yeah. So let's say A2 is a bigger area, pressure is still going to be 10, and let's say A1 is 10. So now the force is 100. So what happens? 50, a force of 50 is applied. On the other hand, you get a force of 100. So this helps you lift cars and all. Okay. Okay. Done. Let's move on to the next topic of this chapter. So very important law, Pascal's law. Another important thing you need to know is variation of pressure with height. So what happens when pressure increases what happens with height? So imagine I have a test tube full of water, okay? And I want you to tell me the pressure at A, B, and C. Will all three heights have the same pressure? So if your answer is yes, no. Pressure varies with height. Okay. So the deeper the liquid, more the pressure. So that is why, I don't know if you have seen, you can't definitely see this, but have you heard of this? The dams have walls that are built like this. So there's water here. You can see the base is thick. Okay. You can't see that because there's water there, but dams are always built like this. That is because at the bottom, pressure is very high. So as you move up, pressure decreases. But as you come down, at the bottom, pressure is the highest. Okay. Same thing when you go to high altitude. So if you want to go on to climb Himalayas and big mountains, you have to carry oxygen cylinders because as you go up, pressure will be, the air particles will be less. That's why you have to carry mask and all. Okay, all that is not part of your syllabus, but this is important. As you go down, as depth increases, what happens to pressure? Pressure increases. Okay. So the amount by which pressure increases is given by P is equal to P naught plus rho G H. Okay? Is this fine? Alright, P is equal to P naught plus rho G H. What is P naught? Atmospheric pressure at the surface. Rho is the density, G is the gravity, value of gravity, H is the height or the depth of the liquid. Okay? Next is Archimedes principle. You don't need the formula, it's not there for you, that's why it's crossed. So, if an object is submerged in a fluid, okay? So, imagine I have this, I put this in a fluid, and this experiences an upward force. Okay? So, this is called as Archimedes principle. According to Archimedes, any object that is submerged in a fluid will experience an upward buoyant force. Okay? Now, the upward force is basically opposing the object's weight down. So what happens? The object's weight is downwards. So this is water, any liquid. So this is the object. The weight is acting downwards, but there is an upward buoyant force. Okay. Now this, depending on this force, an object may float or sink. So when does an object float? When does an object sink? An object will float if the upward buoyant force and the downward weight are the same. So they balance. Okay, so the upward buoyant force and the downward weight, if they are balanced, what happens? It will float. You've seen these things that float on water, like the yellow duck is there. No, you've seen in movies. And I don't know if you use it as well. Those ducks, you put it in water, they float. Yellow color ones. So those are because their weight downwards is equally balanced by the upward force. Now what happens if the weight is not be able to balance? If the weight is more, it will sink. So if you jump in water, you are not going to float. That's because your weight is more than the upward force. So your weight overcomes that and you jump down. Okay? Next is equation of continuity. Equation of continuity, again, very easy. Okay? So according to equation of continuity, anything that goes in comes out. So there's a pipe. Any liquid or anything that goes into the pipe should come out. You can see the pipe is such that The area at one end is big, the area at the other end is small. So A1 into V1 equals A2 into V2. So if the velocity at the entrance part is less, it can go out at very high velocity because the value of A1 into V1 should be equal to the value of A2 into V2. Right. So it's just like 5 into 2 is equal to 2 into 5. So area, velocity. Area, velocity. So it came in with a velocity of 2, it can go out with a velocity of 5. So that is equation of continuity. Anything that comes in can move out, should move out. Next is Bernoulli's theorem. This is also a very important, very easy theorem where it says, again you have a pipe, okay? But here there is a height difference. So the lower part of the pipe is at height h1, the upper part is at a height h2. So there is a difference in height and the velocity. Initial velocity is v1 and velocity on top is v2. So here you can see that energy is conserved. Okay, what does that mean? All of the energy. So what are the energies that are going to be involved here? The first energy is the pressure energy. There's going to be pressure because it's liquid moving. Pressure is definitely there. Now this is kept at a certain height. So potential energy is definitely going to be there. And then this is moving particles. So kinetic energy is also going to be there. So pressure plus potential plus kinetic, all three together would become a constant. Okay. So energy is going to be conserved. Now, so total energy before and total energy after would be the same. Now, if you equate them, P1 plus rho 1 GH1 plus rho V1 square by 2 is equal to P2 plus rho 2 G2 plus rho V2 square. So, pressure, potential energy, kinetic energy. Now, if you equate this, you will get this formula in red. My video is getting stuck again. What is happening in today's class? So many of you are learning and these technical issues. What's happening? Oh. Is it any better now, students? Can you please tell me in the chat if it's better now? Is it fine now? If it's fine, can you put some fire so I know it's fine? Yeah? Were you able to understand Bernoulli's theorem? It's fine, Slayer. Okay, done. Maitri, is it okay now? Ritu, can one of you tell me if it's fine now? I think it's because, I don't know. There's some issue here. No, OBS takes a lot of data. Okay. Alright, so let's continue. So Bernoulli's theorem, as I said, it's a combination of pressure energy, potential energy and kinetic energy. Okay, so combining them, you will get this formula. Very important formula. Bernoulli's theorem is also important. Okay. You want the theorem again? Okay, I will explain the theorem again. Is it lagging again? Strucking. What do you mean by strucking? What is this? What is happening here? If it's clear, can you say clear in the chat? Clear? Okay. Thank you, Art World. I'll continue. Okay. So, Bernoulli's theorem. So, someone wants me to explain it once again. Quickly, I'll just say Bernoulli's theorem is when you have one end, the pipe, and the other end of the pipe at two different heights. The first one is at H1 and the second one is H2. What happens when height changes, pressure changes, potential energy changes, kinetic energy need not change, but here it does because it depends on rho. Alright. Okay. So, what we're going to do is we are going to find out that energy is going to be conserved. So here the energy depends on pressure, potential and kinetic. So the formula for pressure is P, potential is rho GH, kinetic is rho V square by 2. Okay, other than MGH, there's another formula for potential rho GH when it comes to liquids. So at one end and the other end, both of these are actually the same. So when you equate them, you will see that the energy is conserved and you will get this formula. Okay? Yeah? Okay. Next thing is viscosity. So viscosity is a measure of how a fluid flows. For example, if you have honey and water, I put a drop of honey and I put a drop of water. Water will easily flow, but honey will stay the same. It will flow, but not as fast as water. So viscosity is basically that. It tells us how the flow of something is resisted. It's a measure of how a fluid flows. Okay, it also tells us how thick or how sticky a fluid is. Alright, now the formula for viscosity is also important. F is equal to minus nu A dV by dx, where dV by dx is the velocity gradient and nu is the coefficient of viscosity. Alright, it tells us how viscous the thing is, how thick it is, how sticky it is, all those details. Okay. Still lagging? See, if my face is not visible, it's perfectly fine. As long as you're able to hear and see the screen, it's fine. Is that happening properly? Next most important thing, Stokes' law. So what's Stokes' law? So Stokes' law describes the force experienced by a small spherical object. Okay? That is moving through a fluid. So imagine I have a huge bottle of, what do you want? Let's put honey because it's sweet, no? Just like all of you, honey is sweet. So let's take a cylinder full of honey and I put a small ball, okay, a metal ball into it. You will see that the metal ball slowly moves. It will not move like when I put it in air, it moves fast. But here it will move very slowly. Right. Why does it move very slowly? Because it is experiencing a force because of the fluid, and that force is basically Stokes' law. Okay? Let me see if my voice is breaking. It's not breaking. Very slowly. Okay? And the formula is F is equal to 6 pi eta r nu. Okay? So this is basically the drag force, the force from the fluid in which it is moving. So that is Stokes' law. And with respect to Stokes' law, we can look at something called as terminal velocity. So terminal velocity is the maximum constant velocity an object has when you move downwards. Okay? So the best example I can give you for terminal velocity is skydivers. So when a skydiver is jumping, you might have all seen this picture where they all hold hands and they form a circle, they float. Right? So from that particular point, they will be falling down with the same velocity. So let's say their velocity is 100. Okay? It's a random number. So let's say their velocity is 100. So from that point till the point they reach Earth, their velocity will be 100. So that is a max velocity they can obtain in free fall. So that velocity is called terminal velocity. But if they fall with the speed of 100, they will die. So what they do? They put a parachute. So the parachute will make them slower. Okay, because it is going to be, it's big, so more air resistance comes, so they will slowly come down. Okay? Yeah. So that is terminal velocity. It is the maximum velocity an object can attain. So it cannot go faster than that. Okay, and once it reaches terminal velocity, it falls down at constant speed. Alright, now the formula for that is also important. V by T equals 2 by 9 R square rho minus sigma G by eta. Okay, I've also said what each term is. You can go through that. No Tejas, now I'm only seeing physics videos to teach you all. Okay, next one important thing is the Torricelli's theorem. Okay, yeah, this I have seen, questions from previous papers regarding this. So I'm a little pathetic at drawing. So imagine this is a tank, okay? Okay, don't look at the figure. Let's see, there's a tank. This is a tank. I make a small opening on the tank. So what happens? Water comes out, right? Okay. So Torricelli's theorem tells us how fast a liquid flows out if a hole is made at the bottom of the container. See, such a simple concept, but it has a very fancy name. So I have a container, or I have a water tank. I make a small hole, water comes out. So this theorem only tells us how fast water comes out. Okay, you might be wondering why people have made such fancy names for such simple things, because when you go to higher classes, when you learn more physics, all this will be very important. Because you'll measure how the water comes, what angle it comes, and so many things. Okay, so Torricelli said that the speed of the water coming out of the hole depends on how high the water is. So if my tank is here, the water comes out at a speed. If my tank is here, it comes out at a different speed. If it is here, it comes out at a different speed. So as it goes up, as the height increases, the speed increases. Now it's an interesting conclusion, right? So the speed, the relation between speed, height and all that is V equals root 2 into G. Okay? So that is the simple concept. And there's one more formula here, R. R is the how far it goes. R is square root of 4h into h minus h. And you have to understand what each h is. Capital letter H is the height of the whole tank. Small letter h is the height till the hole. This is small letter h. Here is the hole. Water comes out. This is capital letter H. Okay? Alright. Let's move on. Next is surface tension. When height increases, see how high the water level is. So higher, more faster. So it also depends on the hole. So if the hole is near the bottom, okay, if the hole is near the bottom, if the hole is here, water comes out faster. But if the hole is at the top, water comes out slowly. Why? Because pressure is more at the bottom. So if the hole is at the lower the hole, faster the water comes out. And what is it? Small h, the height of the hole. So if the height of the hole is very big, which means height is low, right? That means water comes out quickly. Okay? Is that clear, Gagana? Okay, now what is surface tension? Surface tension is a property of a liquid that makes it behave like a stretched elastic sheet. So you might have seen some liquids, when you put soap and all on water, it forms a sheet kind of thing. That is because of its surface tension. So surface tension is a property that makes it stretch like an elastic sheet. So it is basically force by area. Now there's something called as surface energy as well. What is surface energy? Surface energy is S into del A. Del A is again the area. Okay. Next what we will see is we have to look at the work done to blow a liquid drop and the work done to blow a soap bubble. These two only formulas are required. So basically work done is what? S into A. Yeah. So W is equal to S times delta A. Now delta A is what? 4 pi r square. So S times 4 pi. There are two surfaces, the inner surface and the outer surface. So that's why instead of r square, it becomes r2 square minus r1 square. So this is the work done on a liquid drop. But on a soap bubble, what happens? You can look at this. On a soap bubble, it has two surfaces. That is why you have to multiply 2. So that is the only difference in the formula. Okay, for liquid drop has only one surface. A soap bubble has two surfaces. So the formula becomes 2s. 4 pi r2 1 minus r1 square is the same. Alright? Is this clear? Fine. So this surface tension is for a liquid. Okay. Surface tension is for a liquid. It is the property of a liquid that makes like a membrane. It is not something that is applied. So it just forms like an elastic sheet. Okay. Alright. Let's move on to the next topic, which is capillary rise. So what is capillary rise? Okay, so imagine I have a container and I have a capillary tube. So what happens? The water level in it rises. So when a narrow tube, it is dipped in a liquid. Okay, this is a container full of water and I put it. Still buffering. Okay, I put a container, I put a capillary, I put a test tube, anything. So what happens? The liquid inside starts rising up. So liquid always flows down, that we know. But now what happens? Liquid goes up. So when liquid goes up, that effect is called capillarity. Okay. So when liquid usually flows down, but here liquid goes up. So this capillarity is given by this particular formula, where S is the surface tension, theta is the angle of contact, R is the radius, density, G is gravity. Okay. Now for capillarity, there is also two things that you need to know. There are two kinds of forces, adhesive forces and cohesive forces. What are adhesive forces? Adhesive forces are forces of attraction between molecules. Okay. So if there are two molecules and they attract, they're different kind. One is water, one is soap, or one is glass, and they attract, it is adhesive. But what is cohesive? Two molecules of the same kind attract. So a glass of water has water particles, they are all cohesive. But some water particles stick to the glass. That is adhesive. So if the adhesive force is greater, then you can see capillarity, that is the liquid will rise up. Okay. What do you mean by adhesive greater than cohesive? That means it is going to stick to for example, the glass. It is not going to stick to each other more, it's going to stick to the other particle more. Now, if cohesive is greater than adhesive, that means the water particles stick together towards themselves. That is when it falls down. Okay. So, adhesive greater than cohesive, an example is water in a glass tube. Okay. Cohesive greater than adhesive is mercury in a glass tube. Okay. Is this much fine? Next is the thermal properties of matter. So what are the main things that can happen in matter? One thing, imagine I have a solid. The moment I heat it, okay? The moment I heat it, it will expand, it will increase its length. So that is called linear expansion. Increase in length is linear expansion. So what is linear expansion? L2 equals L1, 1 plus delta T. T is the change in temperature. L1 is the initial length. L2 is the length that increased. Okay. Alpha is a constant. Next is superficial expansion or area expansion. So imagine I heat it and the whole area increases. Not just the length, but the whole area increases. So when the whole area increases, what happens? The same formula, but instead of L, it becomes A. Instead of alpha, it becomes beta. Same thing. You just have to learn one. You can just keep changing the values. Next is volume expansion. So again, I heat something, but the whole volume increases when I heat it. In that case, what the formula will be? It will be V2 equals V1 1 plus gamma delta theta. And how does alpha, beta, gamma vary? They vary in the ratio 1:2:3. So if alpha is 1, beta is in the ratio of 2, gamma is in the ratio of 3. Okay, so beta would be 2 times alpha, gamma will be 3 times alpha, right? So what is alpha is to gamma is 1:3. So gamma will be 3 times alpha. Okay, you just have to remember 1:2:3, but how do you apply it? Okay, so you can see gamma is 3, alpha is 1. So that is how you get gamma is 3 times alpha. Beta is 2 times alpha, right? Because alpha is 1, beta is 2. So beta is 2 times alpha. Okay, so these are the different expansions: linear expansion, superficial expansion or area expansion, cubical expansion or volume expansion. You just have to learn the formula of one and then you can change A, B and L, and the constants alpha, beta, gamma, they vary like this. Is this clear? Are you all sleeping? Can I have some fire emojis in the chat? Fire, 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 full of energy. Can I have some fire emojis or some claps? Clap for yourself. See, whenever you study, you should keep on appreciating yourself. You should tap on your shoulder and say good job. Okay. So now you can clap in the chats and say good job. Did you all like the video? If you haven't liked the video, please go like the video and come back. Quickly, students. Can I have some emojis? Are you all here? Thank you, Nani. Others? Yes, Kalpana. Yeah, you should self-appreciate. Clap for yourself. Okay. Next is specific heat capacity. What is specific heat capacity? I'll tell you in simple terms. Okay. You have milk. Okay. Let's say this is a good job, Slayer, as well. Okay, you have a jar of milk. Okay, this is a mouse, but imagine this is a jar of milk. Okay, this has full milk, and I keep it on a stove. Okay, I measure the temperature of the milk. It is how much do you want? Some random number. So the temperature is 29 degrees Celsius. The temperature of the milk, and I keep it on a stove. I'm heating it. I will measure how much heat I should have given for it to become 30 degrees Celsius. That is my specific heat capacity. Okay, so it is the amount of heat that you should give something to increase its temperature by 1 degree Celsius. Okay, so anything. So imagine I have a liter of milk, water. So if the water is at 80 degrees Celsius, how much energy I should give it to increase its temperature by 1 degree? So 80 should become 81. That is specific heat capacity. It is the amount of heat required to raise the temperature of a substance by 1 degree Celsius or 1 Kelvin. Is that fine? Good? Good to go? Yes? You can just switch off the chat, dear. Switch off the chat and watch the video. But you can open the chat if you have to ask doubts or when I ask you to put fire or clap or something. Alright. Next is, this specific heat capacity is represented by the alphabet C. Okay. Generally, specific heat capacity is C. But with respect to change in pressure or volume, I can make it as Cp or Cv. Now, what is Cp? Cp is when the change in temperature, that 1 degree increase in temperature happens at constant pressure. Okay. So, pressure is not changing. So, generally, the formula for specific heat capacity is Q is equal to mc delta T. This is a general formula. Now, at constant pressure, it becomes Q is equal to mCp delta T. Okay? Now, what happens? There's one more case where you have specific heat capacity at constant volume. So, the temperature is increasing, but volume is not changing. So, in that case, you will get Q is equal to mCv delta T. C just becomes Cp and Cv. Okay? So, what is the relation between Cp and Cv? If you subtract Cp and Cv, you will get R, which is universal gas constant. You might have learned this in chemistry. 8.314. Okay? Yes, Ashu, I will. Alright. So next is calorimetry. Okay, specific heat capacity clear. So there is Cp and Cv as well. Next is calorimetry. So heat is the energy transferred from a hot object to a cold object. Heat never flows the other way. It's always from the hot object to the cold object, and it's measured in joules or calories. So a calorimeter is a device that measures this heat exchange. Okay, so calorimeters usually are insulated. Why are they insulated? Because it has to actually measure how much heat has been exchanged. So this heat should not escape to the surrounding. That is why it is always insulated. And calorimeter works on the principle of calorimetry. What is it? If you have two bodies, okay, you imagine you have a cup of coffee. All of the heat lost by the coffee is gained by the surrounding around it. Okay, so if you have a cold body, the heat gained by the cold body is equal to the heat lost by the hot body, if there is nothing lost to the surrounding. So my cup example is just a simple example, not the ideal example. So in ideal case, I have two objects. One is hot, one is cold. So all the heat gained by the cold body is equal to the heat lost by the hot body, if none of it is lost to the surrounding. Okay, so Q lost is equal to Q gained. Is that fine? This is a principle of calorimetry. Now there's a formula for this as well. So MC is, okay, so what is specific, the heat? Q is MC delta T. What is delta T? T1 minus T. Okay, now if you have two bodies, alright, and such that the temperature is T1 has a very high temperature, this is T1, and then there is T, then there is T2. Okay, so all of the temperature of T1 will be transferred to T2. In that case, the specific heat capacity can be calculated like this. So as I said, Q is equal to Q. Q initial is equal to Q final. What is Q? MC T1 minus T. Okay, this is the principle of calorimetry. Next one is latent heat. So don't get confused between specific heat capacity and latent heat. Specific heat capacity is what? Specific heat capacity is the amount of heat required to raise the temperature of something by 1 degree. But specific latent heat is basically the amount of energy that you need to change state. For example, you want ice to become water. Okay, so that change is because of latent heat. So latent heat is when one thing changes from one to another, one form to another, one state to another. You can see in this graph. So I will draw it with a blue line. So you can see, imagine I have ice here. Okay, you see the blue pointer. So there I have ice. Okay, and then I am putting it on a stove. So the ice is still ice for some time, but after that point, it starts melting, and then it becomes water, then it starts boiling, and then it becomes vapor. One straight line in between. So that straight line actually means it is at one single temperature. The temperature is not changing. But why does that happen? That happens because the state is changing there. Understood? So ice is becoming water, but ice has to have some energy in it. It has to absorb some energy to break bonds and become water. So at that line, the line part is the part where change of state happens. So during specific latent heat or change of state, the body absorbs the energy, but it does not use the energy to increase its temperature, but it uses that energy to change state. Okay, once it has all changed state, then what happens? Then it slowly starts increasing temperature. Then it increases temperature till it reaches its boiling point. Once it reaches its boiling point, again the water uses that energy to break bonds and become water vapor. So that is why you see this stagnant bands where there is no temperature increase. Because at those places, temperature is used to to change state. Is that clear? Okay. So there are two kinds of specific latent heat of fusion and vaporization. Fusion is the heat required to change from solid to liquid. Vaporization is from liquid to gas. Okay? Okay. Next is the three main heat transfer: conduction, convection, radiation. Very simple. Conduction is when heat transfers through direct collisions. Convection is when it's mainly in a liquid. Radiation is when it's through electromagnetic waves. Okay. Now the rate of flow of heat. So if you have a pipe, heat flows from one end to the other. So how does heat flow? Okay, so the amount of heat flowing is going to be a constant. It's going to be Q, and L is the length of the conductor. So you can see the rate of flow H is given by Ka times T2 minus T1 by L. Where this K, so we learned so many Ks. If it's related to springs, it's spring constant. If it's related to energy or heat, the K is called thermal conductivity. So thermal conductivity into area is basically T2 minus T1 by L. L is the length of the object. Now there's one more thing that you can do is the amount of heat flow. Okay. So the amount of heat flow is Q, which is H into T. What was H? H was the rate of heat flow. So this is the formula for H. This is the formula for Q. Okay. There's an extra T. That's all. Alright. Next is thermal resistance. Thermal resistance R is equal to L divided by Ka, which is del T by H. Now, thermal resistance can be in series and in parallel. So, when two conductors are attached in series, what happens? The total resistance is R1 plus R2. So, it is given by K is equal to L1 plus L2 divided by L1 by K1 plus L2 by K2. But if they are in parallel, so they have Q1, Q2, K1, K2, and then the sum is 1 by R1 equals 1 by R1 plus 1 by R2. So, conductors also can be attached in series and in parallel. Okay. Is this fine? Yes. Next, very important topic in this chapter is Newton's law of cooling. There has been questions from this. I've seen questions from this. Newton's law of cooling. What is Newton's law of cooling? Newton's law. Yes, I will do last chapters also. Newton's law of cooling states that the temperature of an object is directly proportional to the difference between the object's temperature and the surrounding. So, imagine one object is at 50 degrees Celsius and the other wants to become at 100 degrees Celsius. Sorry, 150. Okay, so the 100 degree one has to cool to 50. How it cools depends on the surrounding temperature. So if it's in the fridge, it will cool faster. If it's outside, it will cool slower. Right. So how something cools depends upon its surrounding temperature. So you might be given a question like, yeah, something like this. So a body might take 35 degree. A body is at the surrounding temperature is 35. It wants to cool from 70 to 80. Okay. But now the surrounding temperature increases. How fast will it cool down? So for such questions, you know T1, T2, you know Ts also, the surrounding temperature. And for this, the time taken is 5 minutes. So what you do with this formula, first thing you find K. Okay. So you find out K. This is the formula. Right. So you find out K. Okay. So with K, what you will do? You will find out the change in temperature. Do you understand where to apply this? So imagine you have a system which is at 100 degree. You have another one. You want to cool this to 50 degrees. But the surrounding temperature is 35 and you cool it in 5 minutes. Now the question is, the surrounding temperature increases to 45. How much time will it take for this cooling? So what you have to do is, with the first conditions you had, with the first parameters you had T1, you had T2, you had the surrounding temperature, you find out K. And then you substitute that, find out the new time taken. Okay? Thank you, Gagan. Alright. Is this much clear? So that's the end of that chapter. One more chapter done. Now we only have hardly 3 chapters, no? Thermodynamics, waves. And then I'm not going to do this one. KT, okay, kinetic theory, because it's too long and it's not worth studying. You will only get one question from it and it's too long. I don't want to waste your time. That's not important. It's not that it's not important. It's too much of work. Okay? If you're all there with me till now, can you clap? Applauses. So this is just the formula, the derivation part of this formula. Okay? Did you understand how questions will come from this? Can I have some energy in the chat? Some claps or some fires, something before we move on to the next chapter, which is thermodynamics. Yes, ma'am, what is it? Yes. Who are you? I am a physics teacher. Okay. Yeah. Appreciate yourself. You've been listening to physics for 2 hours. You can be good. You can be proud of yourself. Okay. Next is thermodynamics. So thermodynamics is basically telling you about heat. So some important terms that you need to know in thermodynamics. First one, what is an open system? What is a closed system? What is an isolated system? What is an adiabatic system? What is a dithermal wall? Adiabatic wall and dithermal wall. So, an open system is a system that can exchange energy and matter with its surroundings. Okay? Mhm. An open system is a system that can exchange both energy and matter. Closed system can exchange only energy, no matter. Isolated system can not exchange no energy nor matter. So it is completely closed. Whatever is there inside stays inside. See, an open system is like a hot cup of tea. It can exchange. A closed system is like a closed cup of tea. It can still exchange energy. Isolated system is like a flask. It cannot exchange energy. Adiabatic wall is a wall that does not allow heat exchange. So if there is an adiabatic wall, heat will not pass through. And a diathermal wall is a wall that allows heat exchange. Okay, this you will use when we learn the zeroth law. So what does the zeroth law state? If I have three systems, A, B and C, all of them will have the same temperature. See, between A and B there is an adiabatic wall. What does that mean? Adiabatic wall does not allow heat exchange. So heat is not actually being exchanged. There is no heat exchange here. But A and C can exchange heat, B and C can exchange heat. So A and C exchange heat and they become the same temperature. B and C also exchange heat, they become the same temperature. So at the end, A, B and C will become the same temperature. All three will have the same temperature. So that is zeroth law of thermodynamics. So if these systems are in equilibrium, then what happens? They all will have the same temperature. Now the first law of thermodynamics says that whatever energy you give to a system, some of it is used to do work, the other is used to increase its internal energy as well. That is du plus dw. Okay, so du is increase in internal energy, dw is work done. Okay, so whatever heat you give, some of it is used to do work, the rest is used to increase the internal energy of the system. Okay, now the work done is positive as volume increases, negative as volume decreases. And then you need to know about the basic processes. Here you only need to know what all is constant. So in isothermal, isochoric, adiabatic and isobaric, you need to know what all is constant. Okay. So in isothermal, what is constant? It is a process in which temperature remains constant. Okay. So temperature of the system remains constant. Now isobaric is where volume remains constant. Isobaric is where pressure remains constant. And adiabatic is where there is no heat exchange to the surroundings. Okay, that's all you need to know. Isothermal, adiabatic, isochoric and isobaric. What all is constant there? Is that fine? Next, cyclic process, very important. So cyclic process is a process which is a closed loop. So wherever you start, you come back there. Okay. So whatever route you take, you always come back. So whatever changes happen, it's all coming back. So whenever you have questions to find out anything in these, you can always find out the area under the graph. Okay. So if the question is find out the work done for this cyclic process, what will you do? You will find out the area enclosed. Very important. So work done is area enclosed. Now if the path, you can see this arrow. If the path is anti-clockwise, work done is negative. If the path is clockwise, work done is positive. Very important KCET point of view. Okay. If it's anti-clockwise, it's negative. If it's clockwise, it's positive. Alright? Yeah? Samjha? Okay? Now, del U is 0. So, in this case, that means all the energy is supplied to do work. Because if some energy is lost, it will not be able to form the closed loop. So, there is no internal energy increase. Whatever energy you are giving, all of that is done used to do work. So, the efficiency is work done by heat supplied. Because only then you will get a closed figure. If somewhere some energy is lost, then this closed figure won't be there. So, no, there is no del U. Okay? All the energy is used to do work. Alright? Next is heat engine. Heat engine is deleted in your syllabus, I guess. I will just quickly tell it. There's a source, there's a sink. So heat flows from the source to the sink, and the formula is 1 minus T2 by T1. Now, Carnot's cycle. Carnot cycle just tells you, how something changes from A, B, C, D. So you can see from A to B, there's isothermal process happening. From B to D is adiabatic. From D to C, it's again isothermal. C to A is adiabatic. And how are the formulas varying? Q2 by Q1 equals T2 by T1. Okay, so it describes how a heat engine works. So there are two regions where there is isothermal process happening, two regions where there is adiabatic happening. So in two regions, there is no heat exchange. Two regions, there is no temperature change. Okay, this is fine. So yeah, that's all that you need to know here as well. And then the second law of thermodynamics, no heat engine is 100% efficient. There's always some way for it to lose its heat. Okay, it will always lose its heat. So what all do you need to know here? Second law, Carnot cycle, cyclic process, very important. All of these four processes, what is constant there? First law of thermodynamics and the zeroth law. That's all. Very easy chapter. Okay, so thermodynamics is done. Next, we have only two more chapters, oscillations and waves. Okay, can we all clap for ourselves? Some clap emojis, some fire emojis in the chat. Yes, can you all tell me how is it going so far? Going good or bored or done? Don't want to do physics anymore? Okay, oscillations is very small, we'll finish it quickly. I'll finish the class soon. Okay. Yes, self-applause. Are you all okay? Is there anything you don't understand? If there's anything, you can actually let me know in the chats. Okay. The last two chapters, very important chapters. Okay. Next is oscillations. In oscillations, what you have to do is you have to look at, you have to look at some formulas. Formulas everywhere, no? That is physics. So, yeah, I know everybody's chatting with each other. Nobody's listening to my class. It's okay. Okay. So, harmonic motion. So, first thing, when something moves like a pendulum, okay, its motion is described by A sin omega t and A cos omega t. Okay, it's A sin omega t and A cos omega t. Its velocity is given by omega in times A square minus y square, and its acceleration is minus omega square. Velocity is A omega. Maximum acceleration is minus omega square. Restoring force is minus omega square x. Angular velocity. All of these formulas are important. Okay. So for oscillations, first thing you need to learn is you need to learn these formulas. You need to learn the formula for simple harmonic motion, for velocity, acceleration, maximum velocity, maximum acceleration, and restoring force. Thank you, Naveen, for listening. Okay, so if you have a pendulum, the central part is where the acceleration is 0. That's where the velocity is maximum. Okay, So these are all direct substitution formulas. Next is the energy in simple harmonic motion. So energy in simple harmonic motion, kinetic energy is half m omega square a square minus x square. Potential energy is half m omega square x square. There is no a square there. So total, when you add these two, what will you get? You will get half m omega square a square. Okay. Next, time period formulas. These are also important. I've seen questions from these. So there's two time period formulas for simple pendulum and for a spring pendulum. What is a simple pendulum? Simple pendulum is a pendulum on a simple thread. You might have done that practically in your school. So you have a pendulum and then you just measure its swinging oscillation. So the time period is 2 pi root L by G. So you should know this formula because you had a practical, right? Simple pendulum. Next is spring pendulum. For spring pendulum, what happens? It is the G, gravity factor, is replaced by spring constant K. Okay? And the length is replaced by M. Alright. Okay? So simple pendulum and spring pendulum. These are the two different kinds. Next is the effective spring constant. Okay? What is effective spring constant? It is how two or more springs combined together give you the effect. So here first thing, two springs are in parallel. So when two springs are in parallel, the total spring constant will be the sum of the two. When two springs are in series, that means one is after the other, then the spring constant will be the reciprocal. So you will need this, to find out which one, doing it in which way gives you a good effect. Which method can hold more mass. So you just have to find out the spring constant of these. Okay? That's all. Oscillation is done. In oscillation, you have to find out, for effective spring, how spring constant varies, simple pendulum formulas, kinetic energy formula, potential energy formula. Then 4 formulas. What all? Force, acceleration, velocity, and harmonic motion. That's all that you need to know. Hardly take 10 minutes to learn oscillations. These formulas are easy formulas. If you write them twice, you'll learn them. Okay? So oscillations are easy, right? Only this much. This is so important. Okay? So I am giving you a gist of what is there in the big chapter. I can't teach you the whole thing. I'll have to take classes for 2 or 3 days. But whatever is, something that's very important, whatever I could find out, I've put it here. Okay? You can do well with this, is what I believe. Alright? Okay, one more chapter done. Applauses. Can I have some fire? Can I have some claps? In the chat. Students, only one more chapter is left, which is waves. Kinetic theory we're not doing because it's too long. You don't have to waste your time learning that. Anyways, hardly one question will come from that. So let's not learn that. Okay? I mean, as a teacher, I shouldn't be saying that, but as a in a KCET perspective, you don't have to take so much effort because you already have lots to study. So last chapter is waves. Shall we start waves? Yes? Yes, Naveen. Over. Waves more. Waves is easy, not a lot of derivations. Slayer is back. Where were you, Slayer? I haven't seen you for some time. Go invite all your friends who went off. The last chapter is happening. Call all of them. Let's do the last chapter. So waves. Yes, waves is very easy. So we'll quickly just look at waves in like 5 to 6 minutes and then we will wind up. Okay. So there are two kinds of waves. Transverse waves, longitudinal waves. Transverse wave have this up crest region. This is called the crest. The lower part is called the trough. Okay. And then longitudinal. What is a transverse wave? A transverse wave is a wave where, the wave. Okay. Imagine this is a pole and I attach a string to it. Okay. And I try moving the string. When I move the string, what happens? Waves are formed. This wave is moving in the forward direction. But if I look at a particle on the rope, it is moving up and down. So every particle is moving up and down, but the whole wave is moving forward. That is a transverse wave. Longitudinal wave is like a spring. So I compress it. The whole spring is moving like this. The particles are also moving like this. So the particles and the wave both are parallel. Okay. In the other case, particles and the wave propagation is perpendicular to each other. Alright. Okay, Slayer, good. Alright. Okay. Next, some important terms that you need to know here. Angular frequency. Angular frequency is 2 pi by lambda. F is c by lambda. So angular frequency can also be written as 2 pi by f. Frequency is 1 by t. Okay. Alright, next is standing waves. So what are standing waves? Standing waves are the waves that are formed by two identical waves but traveling in opposite direction. What is that? So imagine I have a wave like this. I have another wave like this. So this is a standing wave. They are the same, okay? My drawing is bad, but actually they should be the same but in opposite directions. Like this, the blue one and the green one. So they cancel out. Okay? So the wavelength, the length of one wave is lambda. Alright. Now these are, okay, now nodes and antinodes. What are nodes? Nodes are points where the waves meet. Antinodes are the central points. So every time a wave meets, it becomes a node. Every time a wave separates, it becomes an antinode. The position of nodes and antinodes are given by x is equal to n lambda by 2. The position of antinodes are given by x is equal to n plus 1 by 2 lambda by 2. Okay. Alright. So this is nodes, this is antinodes, this is the general formula. What else do we need to learn here? Yeah, now you need to know two things. What is fundamental frequency? Okay, fundamental frequency is the lowest frequency. Now, harmonics is an integral multiple of fundamental frequency. Okay, so if the fundamental frequency is 1, harmonics would be 1 into something. If the fundamental frequency is 4, harmonics will be 4 into something. It will be some integral multiple of that. Okay? Yes? Have you all liked the video? Can you all go like the video if you haven't liked? I'm sure all of you liked it. Okay. Next is, what we're going to see is vibrations that are going to be shown on a stretched string. Okay? So, the string is here. In the first case, I have only attached one end. So, two things you already know, fundamental frequency and harmonics. Fundamental is the first frequency, harmonics is the integral multiple of it. Now, what we're going to do is, we're going to take a string where only one end of the string is attached. I've only attached this one end. Okay? So what happens once I make vibrations on the string? The first vibration is going to be a V by 4L. You need to learn that. The first vibration is going to be a V by 4L. Now the second one is the third harmonic, which is going to be a 3V by 4L. Now the next harmonic is going to be 5V by 4L. So you can see each of these are integral multiples. So the first harmonic was F0. The second harmonic is 3F0, which is an integral multiple. The third harmonic is 5F0. So when the string is attached to only one end, how does the frequencies vary? The harmonics vary. F0, F1, F2 varies in the ratio 1 is to 3 is to 5. Now second case, I attached both the ends. So now I have waves on it that look like this. So the first wave here is going to be V by 2L. When only one end was attached, it was V by 4L. For both ends, the formula is V by 2L. So now the second harmonic would be 2V by 2L. The third harmonic will be 3V by 2L. So F0, 2F0, 3F0. Now how will these be? The ratio would be 1 is to 2 is to 3. Here the ratio was 1 is to 3 is to 5. Okay. So these are the two cases. Waves, vibrations on a stretched string. One is for one end fixed. The other is for two ends fixed. Is that clear? So you have the first harmonic, third and the fifth. Here you have 1, 2 and 3. Alright. Now one more topic in this chapter is organ pipes. What is an organ pipe? An organ pipe is a tube that is used to produce sound by an air column. It's just a pipe which has air inside and you make sound with it. There are two ways in which you can do it. You can open the organ pipe at both the ends, or you can close the organ pipe at one end and the other end can be open. So in this picture you can see, okay, so here you can see. So the first row, which is all of this, is where the organ pipe is open at both the ends. Okay, it is open at both the ends. So what happens? For the first harmonic, what happens? This is how the wave is. For the second harmonic, the wave is like this. Third harmonic, it is like this. But look at the open one, the closed one. See, the wave is like this. So there is only one node which is at the end. Here there is one node and two antinodes. For the open one, there are two antinodes, one node. For the closed one, it is one node, one antinode. So that is how it varies. Okay. So you can actually see the first harmonic is V by 2L. You can see for an open node, the first node is at 2L. So it is V by 2L. And the wavelength is 2L. So all others will be at n times V by 2L. So it could be 1 V by 2L, 2 V by 2L, 3 V by 2L. It just keeps continuing. Okay. But for a closed one, the first harmonic, see, it is at V by 4L. So its integral multiples will be NV by 4L. So so how can we compare? Vibrations of a stretched string on one end fixed is similar to which one? It is similar to closed organ pipe. Okay? If it's fixed at both ends, what happens? It is similar to open organ pipe. Is this clear? Is this clear? MCQs PDF, I've already done a video on some MCQs for first PU. It doesn't have all chapters, but some chapters MCQs are already done. Okay. You can check that video. The PDF is there under the video. Alright. So, that's all. We're done. So, in waves, what are the important things that you need to know? There are standing waves. Okay. For standing waves, the formula, position of the nodes, position of the antinodes. And then, what is it? And then there is vibrations on a stretched string on one fixed end and two fixed ends. And then this can be compared to organ pipes. So you need to know the first harmonic or the fundamental harmonic. With respect to this, you can find out the third and fifth harmonics. Okay. So here, it's fixed at both ends. So here also, you can look at the first harmonic. With respect to that, you can write down the second, third, how many ever harmonics you can do. Alright. So this is all that you need to know in waves. Now kinetic theory I am not doing because it's a long chapter and you wouldn't have time to study all this. So from all this you will at least get one question from one chapter. And the questions from first PU are not that difficult compared to the questions from second PU. I wouldn't say they're easy, but compared to the questions from second PU, the questions from first PU are better. So that's why I did a video on first PU, because these are topics, these are just some formulas are complicated, I know. Some formulas are difficult to learn, so write and study, students. And don't worry, okay? One thing that you shouldn't do, don't panic and simply learn this and that. Whatever you learn properly. You make sure that if you learn waves, you have to make sure that if a question from waves comes, you should be able to answer. You learn it like that. Okay? Yes, Naveen, successfully 3 hours completed. In 3 hours, see, I could have explained the derivations in detail, but it's going to take a lot of time. And I don't want to waste so much of your time with first PU portion, because you only need to know the formula. The derivation is not required. Okay. So all of this is a summary on everything you need. So I will share this PDF with you. You can go through this. If you have any doubts, you can ask me now. Anything, students, anything you want to ask me, you can ask me now. So I think I've covered almost all important things. I won't say I covered everything, but important things I've covered. Unless just 4 questions are from only this. But you can never say. But usually it's from this. Okay? So thank you all for being with me. And I wish you all the very best. So we will have some more classes. But I want all of you to do well. And don't panic. Okay? It's just another exam. This is not the end of your life. So whatever you study properly. Otherwise, don't simply sit and study and then go to the exam hall and forget everything. Okay? relax. Whatever you study everything. Okay, I will support RCB Rajat. Okay, don't worry. All right. Yeah, Slayer. Yeah, that was the only intention of this class. You see, these are all things you have already learned, but you learned it 1 year back. So I just wanted you to see all those and remember, okay, there are things like this. I didn't. My intention was not to teach you everything, but it's just like a revision, and I hope I've done that. So please let me know if the class was good. Let me know in the comments so I can, it's something that motivates me. So it would be sweet of you if you could write in the comments how the class was and go like the class. Thank you so much for your time. So I'll see you all with another class sometime later. Bye bye. Take care.